It was an excellent party. I saw some of you back there, and it's pretty amazing that you were able to get up. Well, welcome to the third day of PyCon. Today we have a mixed day of Slovak and English presentations and workshops, and we're very glad that you made it here. Of the President of the Slovak Republic, Andrej Kiska, and we're very grateful that we have, the recognition that this event is happening here. And a few housekeeping rules. We will just go through these very quickly. In case you are not online yet, this is the Wi-Fi password. If you tweet or use Instagram or Facebook or other social networks, the official hashtag is PyConSK. And during the presentations, you can go to slido.com or slide.do and use the hashtag PyConSK to be able to ask the questions. By purchasing the tickets, you already agree to the code of conduct, which you are expected to keep. And also, we're very grateful to our sponsors for sponsoring the event. And they already had addresses. They already greeted us during the past days. We're also very grateful to Red Hat, one of our sponsors, as well. And if you want to check out the schedule, it's available on the website as well, as in mobile apps that are in Apple's and Google's app stores. So please go ahead and check them out. All right, this is already done. This happened yesterday. Today there will be some more informal events, so if you're interested, please get in touch. Thank you so much for being a part of the Python community. There's members of a number of countries who are present here and whom we also greeted yesterday. We'd be very grateful if you find a few minutes of your time to fill out the feedback form so we can improve in the future and in the organization of other PyCons. All right, and that's it. And with that, I would love to welcome Jana Chwalkowska from Red Hat. And we're very excited about what she's going to share with us about the culture at Red Hat. It's a very, very interesting company, and it's amazing that there's a big development center just around the corner in Brno. So the floor is yours. Jana Chwalkowska.
So thank you very much. Thank you all for coming. I appreciate it. It must have been for some of you a little bit of pain because of the social events, and after coming for the third day is always a bit tricky. I'm impressed. I'm impressed by PyCon. I'm impressed also by the fact that you got auspices of your president. I can't imagine this happening in Czech Republic. Just for those of you that know our president, I really admire that your president is actually interested in supporting this event. What I would like to speak of today is a little bit about Red Hat culture and about how we approach diversity and how we are trying to keep our culture entertaining. Which is partially my job in Brno. I'm senior HR manager for Eastern Europe, and the majority of my associates are seated in Brno. We've got about 900 Red Hatters in Brno, over 1,000 in Czech Republic, and the rest of Eastern Europe is 20, 40 at most. So what I'm going to talk about today, first of all, there's a lot of discussion and a lot of interest recently in diversity and inclusion initiatives. And to be honest, before I came to Red Hat, I really didn't understand what this is about, right? Because I don't know how is it in Slovakia or how is it in your countries, but this sort of diversity and inclusion words translated to Czech, they have sort of the bad taste that it's some social activity like that doesn't make really sense, that it's support of people that just, you know, like don't want to integrate in the society. So I was like, okay, like what's this buzzword about? And actually coming to Red Hat, like for me some 9 months ago, like it suddenly started to have quite a lot of sense. So I would like to share a piece of it with you. And then maybe some practical tips or some experience from Red Hat, like according to like what, in my opinion, are the most important elements that are forming the culture in Red Hat to be inclusive and to respect like diverse opinions and to benefit from that. If you have any question during the presentation, just jump in what I'm saying, like, and I will be answering that like straight when you come up with the question. If not, I can talk like hours, you know, like, so no problem. So basically, what is when I was firstly asked by our U.S. like North Carolina headquarters about that I shall you know, like investigate and analyze like whether we are really promoting the diverse and inclusive culture in Brno. I was like what is it about? Like, why should I? Like, we are in Czech Republic. Most of our associates are Czech or Slovak, and like what diversity? But then I realized, okay, like. It's not true that like it's true that most of our associates are Czechs or Slovaks, but we've got nearly 20% of foreigners that are neither Czech nor Slovak in Brno, which is like just quite a big number. We've got a lot of, I will be talking about it later on, like we do a lot of activities to attract actually women, you know, like to be inclusive for people that have like different tastes, different lifestyle, you know, like to be part of Red Hat and to feel comfortable there. And for myself and also sometimes for our managers and for our engineers to actually understand what does Red Hat mean by diversity and inclusion, I came up like with the following overview about like why diversity matters. First of all, first of all, like diversity is important if you have diverse clients. And if you're a software company, you're gonna always have diverse clients if you are a global software company. And if you want to understand them, it's better to have among you somebody who is from the same group or does have like similar preferences as the clients. That's basically the business side of like why to promote diversity and inclusion, like one part of the business side. We actually, in Red Hat, we had like a game about, which was like a pub quiz. If you are familiar with the format that you are sitting in a pub and you have like questions and you work in a team and you want to win. And basically, if you start with pub quizzes, usually like people that know each other and that have similar interests tend to hang in the groups and work on the solution for the pub quiz, right? But then how would you select your team if you knew that there will be questions from Japan history? And you definitely want to win. So basically, like, what would you do? You would probably look up for the Japanese guy that works in Red Hat for already 2 years and you never talk to him because there's high chance that he's gonna understand, he's gonna have the best knowledge of Japanese history. And if you know there's gonna be questions in Russian, then you're probably gonna go for that guy like who's from Russia, who's sitting there in the corner, you know, with his headphones all the time, and you know, like, so we were trying to use this case, you know, to show that if you have multiple, that in the end, like, it makes sense in a diverse world to have like diverse team to work with. And that it's also important, you know, like not to hang just with your group and people you know, but to maybe sometimes at some point have a look somewhere else and try to include somebody who's maybe sitting there like in the corner with his headphones because he doesn't speak Czech and everybody in the office speaks Czech, so he doesn't really join the group. I will be talking a little bit later about like what we are doing to include expats a little bit more in the life in the office. Another case for diversity and inclusion is innovation. And I think that you all work in or are active in open source and like, you know, mixing up like globally and the possibility to exchange know-how like with people that have completely diverse background and like diverse experience. That's a great source of innovation. There are issues that you're never gonna come up with, like if you wouldn't, you know, like somebody who's maybe from, I don't know, South America or North America coming up with full load of different information than you have. Talent development is important part. For talent development, inclusion is really important. This is something that we are solving like every year with talent review, that maybe there are some people that you don't consider as talent. Like I'm working a lot with our managers, so basically what I'm telling to them, like, you know, not everybody is, you know, like promoting himself or herself, like, you know, it's outspoken and extrovert. You need to reach out like to everybody in your group or everybody with whom you are collaborating to actually find out like whether this person, like what is the talent of this person, and get and help to this person to use the talent. And of course, like if you are expanding, if you are doing diversity actions, you are focusing, for instance, to attract more women into open source, or you are interested in attracting or in including like more expats, for instance, to the developer center in Brno, then you are basically expanding your talent pool and expanding the pool of potential candidates, and just brutally business style, you are expanding the workforce that can work for you. So it definitely makes also like business sense. So what's our recipe in Red Hat? There are elements of our culture that we are trying to actually make stronger and you know, keep as little corporate as possible in order to be able to use fully like our in order to be really able to make us still preserve this feeling of like startup and community and living the open source way. So basically like what we are asking from our employees and what our employees actually ask from us is passion for open source. And it's really, if you come to Brno or if you ever visited our Brno office, that's definitely really strong. That's what most of our new hires say, that they want to work for Red Hat because it's because we are doing software the open source way, and it's really important for them, and we are trying to keep it that way. Also, for diversity, it's important that everybody has the same mission. The mission is not only like to make money, but also to change the world a little, you know, like by making the money different way and actually contributing also to the development of the open source communities. And also like one of our recipes are our values, like courage, freedom, commitment, and accountability. I came from completely different company. Before Red Hat, I was working in heavy industry, heavy machinery, and I was really impressed when coming to Red Hat that basically like the company is letting people to run their own projects. If they find something that they are passionate about and that they think that would be beneficial either for the open source community or beneficial for Red Hat, or in the best case for both, they can go for that. And like other people are just you know, like very spontaneously volunteering for to participate on these types of projects. So when I came from and in my previous heavy industry company, like if you would say like, please volunteers step forward, like everybody would make like a step back, you know. So basically like I was really impressed about that. Well, to come back a little bit about how we are promoting like diversity. If you want to work with people that have diverse backgrounds, diverse requirements, diverse needs, lifestyles, interests, ways of working, one of the most important things for me is the flexibility that we are trying to offer to them, to actually make space for most of their needs. So we've got And we are trying to keep, even though the Czech labor law is not really like in favor of this, it's more like the heavy industry style labor code what we have in Czech Republic. I know in Slovak Republic it's just the same. So basically we are trying to keep as flexible as possible working hours. Basically we don't have like any time clocks, like people need to be there like when they agreed with their manager or with their team, but we are not really controlling this. Again, like big change for me compared to other companies. We are trying to keep as flexible as possible workplace structure. So basically, like there are like spaces where you can work on your own, but then it's mostly open space to work in a team. We are currently building in Brno 4th building, which should be even more flexible, having like small offices, enclaves, like places for teamwork, and all of this is like to cater for different needs. We've got places like, for our associates that don't like light, daylight from some reason. So basically, like we've got like some shaded enclaves. And, as long as this is possible, like we are trying to keep the workplace like friendly to everybody. We are trying also to cater for special needs. For instance, we are offering a broad range like of opportunities for students to work part-time. Also like for mothers or fathers on maternity or parental leave, we are trying to offer them as much possibility to stay in touch with the company as possible. So for instance, recently we started to offer to mothers on maternity or parental leave the possibility to, at least if they don't want to work part-time because like they want to be more with the family, which is completely understandable, but still they were looking for some way how to stay in touch with the very rapidly developing world of software. So we are offering them the possibility to some of them to stay as mentors. So basically they work a couple of hours a week, and they are, if they've got experience, so they are either technical or like talent development mentors for the recently hired, for instance, guys and girls like after the university, or for interns, which is like, in my opinion, like really nice way how to stay in touch, but not to work like standard or like at least part-time hours like when you have a baby. We also offer work from home, usually 1 day a week. There are associates that are fully at home, or they are more than one day a week working from home, which is also really good. On the other hand, we don't want to go for like having all the associates working from home, because like I've noticed that the best, craziest, and sometimes like most innovative ideas happen frequently like when you are waiting like in a line for the coffee machine, in the kitchen. So basically like if you have everybody working from their own kitchen, like you don't have this type of interaction. So but still, like the 1-2 days from home, working from home, is definitely something that enables like a variety of people, a broader variety of people, to be part of Red Hat and still be able to preserve the lifestyle or the needs they have. Another thing that we are doing in Red Hat is a lot of education about how to be more inclusive and how to actually use the opportunity that you have to meet and interact with people from all over the world and with people like from diverse backgrounds. Why is this important? It sounds like a cliche, but to be able to fully use diversity and to be inclusive, it's a skill. Like not, especially if you are formed, for instance, by Czech education system, it's not educating you a lot, like to be like, to understand, diverse culture and, to get involved, like, with people from diverse backgrounds. I don't know how it's Slovak education system, but in Czech Republic it's still this type of like command control system that the teacher is saying something and you write down the notes and then you make exam. but it's not much about like teamwork and interactions and stuff like that. So basically like that's something that at least I feel like is still a disadvantage of the way how we are educated and needs to be trained when people come to the Red Hat office. Red Hat has something that I wanted to particularly highlight, and it's the open decision framework. So basically, if there is like some major change happening, or if there is like, you know, like some program or strategy launched, there's usually a lot of discussion before that globally. So basically like there are like, any associate has the right and the possibility to actually say their own opinion to like the strategy, and usually like discuss how this opinion could be incorporated or not. Again, for me, coming from a very different company, this was at the beginning a little bit weird, because I was like used like for that type of military style company that like the boss said something and like we were like, you know, we needed to start to immediately execute. It was like sort of this style of management, like if you know the Czech fairy tales, like Trautenberg, you know, like I said and you run and execute. So basically this type of style. And here in Red Hat, I wanted to start with a slight change of one directive. I sent the information to our burner list, and I received like, you know, tons of opinions, and I was like, it was not for discussion. It was just I just wanted to inform you that this is gonna happen. No, this is not the way it works, which is really cool. But again, in order to actually have even the shy and introverted associates to fully use this, it needs training, because there are some people that just don't, you know, that just don't naturally go and say their opinion, especially if these discussions are live. Like people are a lot more vocal by emails than they are vocal like when talking in person. So basically like you need to train people that if they want their voice to be heard, they need to speak. You know, it sounds again like a huge cliche, and it sounds really straightforward, but in the real life it's not. We are trying to also, you know, promote like anything where we feel that there's still deficiency of people being part of open source community or being part of Red Hat or Red Hat's colleagues, clients, collaborators, like online. We are promoting women in open source. We are having like different communities of people that have different, you know, that have the same type of interests or same type of background, like Hispanic community in the US or Afro community. So we are trying to get them let their voice heard and let their experience to be shared with the rest of Red Hatters. I was talking already about the openness in communication, but as I said, like it requires training. I had once like talk with one of our very junior manager, and he said, I told to my team that if they encounter any problem, that my door is always open and they can come to me and tell me that there is a problem and we're gonna solve it. And I was like, and what happened? And he said like, nobody came. And I was like, do you think that this means that there is not a problem? And he was like, yeah, because like they can come. I was, no. Like he had already like various people leaving his team, but they just didn't came, you know, like it's the proactive approach that makes the culture like more inclusive. As we are growing, like, you know, that Red Hat, like in Brno 10 years ago, it was 100 persons, like now it's in Czech Republic, like over 1,000. So during this like very high speed growth, we are trying to, it's getting more complex to preserve this inclusiveness and this possibility of open communication, but we are trying to do our best, you know, all hands calls, meetings, question answers calls with the top management in the US, where you can ask like anything that you find interesting. Even last time, like one of the highest voted question was whether hot dog is sandwich. So basically, you know, like asking whatever you want to. I think the final voting was that hot dog is sandwich, but stuff like that. And also like, you know, trying to have this proactive outreach to actually make sure that everybody who has something to say is able to say it, like by some way or another. As to the events, activities, and program that we are supporting, like we are supporting like as much as possible. As you know, like here presented Django Girls by ladies, like the events are usually if they like in Czech Republic or in Slovak Republic we are trying to support events like this financially, also by providing sometimes mentors and are encouraging our employees to get involved. We've got a lot of visits from students from high schools and universities in Red Hat Brno. It's actually pretty funny because there are some, like the colleague that is taking care of this, he usually sends like a warning, like that 4th floor there will be like 30 girls from the from Brno high schools, you know, like coming to visit to the 4th floor, so that everybody knows that you know that this is gonna happen, and maybe, you know, like make themselves a bit more decent than usually, or like, I don't know, like why he's sending it, but it's definitely funny when you come to your office and there is like a, you know, 30 girls standing and listening to information like what type of software is produced in this area. We are trying to promote, like we are doing heavily last 2 quarters. I was working heavily to improve the life of our expats in Brno, because as I said, it's like 20% of employees that do not speak Czech or Slovak, you know, so basically life in Brno can be a little bit like more tricky for them than it would be for somebody coming from Slovakia. You understand everything, that's fine. For Czech people also it's fine. But if you come from Brazil, and we've got like 30 associates from Brazil, like there's a lot of information that you need to know, and a lot more troubles than that you need to deal with, like when you are moving to Czech Republic. So basically we had like questionnaires, people were telling us what is the major problem, and we were trying to address it. Especially like I don't know, like just for pure interest, like the most important problem was like to find a doctor that speaks English, especially specialized doctor. So we had like a lot of like running around asking which doctor speaks like what language, and like making a system for them to actually help our associates to find their way around. We are also trying to find some nice and not command and control way how to promote a little bit more of English as standard working language in our offices. Even though, like, if you are working on a project, you usually speak in English, you usually write all documentation in English, but still, in the standard chats in the office, like it's still Czech and Slovak are prevalent. So we are trying to find some way how to naturally motivate people to speak a little bit more English, so that their expat colleagues can join. But not to do it by like a stupid way, like, you know, saying like everybody now speaks English, and if not, what we gonna do? Nothing, right? So that's the issue. So like we are trying to find some funny way how to motivate people. So if you've got any idea, like I would be really happy to to obtain it from you. And of course we are doing like cultural mashups, like a global village, and like exchanging information about like countries' foods and stuff like that, like anything that can make us closer. Well, so this is about the activities. If you would be more interested in that, like I will be glad to provide you like our full account of activities that we are doing. But since the time is running, so I was talking a lot about like what we are doing in Red Hat to be diverse and inclusive, but does it work? Did we really reach the target, you know, like to be catering for all sorts of talent? Well, partially. We are definitely recognized as leader in some of the initiatives in diversity and inclusion. like our associates actually like this initiative and appreciate it. And from all the questioning that we had, 92% of Brno associates, they believe that Red Hat is diverse and inclusive company, and they like it. According to our survey, 77% of our associates agreed that diverse perspectives are valued at Red Hat, that they feel comfortable sharing their ideas, even if they are different from the rest of the colleagues. So it somehow works. Still, there is a lot to do, right? Like in order to expand, we are trying like not only to invest into our internal procedures and internal processes to get more diversity and more inclusion to our associates, but as I said, we are trying to empower women to actually join the communities, like in open source, empower like people from countries like where they don't have the empowerment like from their education system to actually be able to join the open source family. And it's long run, right? So it's still gonna take some time and some effort, but it's definitely worth it. Like if you're gonna be passing around Brno, like and want to have a look at the at the office and at the mashup that's happening there, just you can definitely come by. Like either my colleagues that you met yesterday and on Friday from recruitment gonna welcome you, or you can just pop me up an email, and like visiting the offices is possible. Definitely, and asking questions is also possible to the extent it's manageable. So basically, this is more or less like what I wanted to say. If you have any questions, like please do not hesitate to ask now, or like I will be like 2 hours. I can stay like 2 hours more, so you can anywhere you're gonna see me. You can ask me questions as well. And are there any questions?
Yes, and there's a number of them actually. So in the next 5 years, what percentage of employees do you expect to work for Red Hat remotely?
Very tough question. I can't say for Red Hat globally. I can tell you that in Czech Republic, I expect it to be like something around 20%. It's not 20% now, it's like 10%. But for Red Hat Czech, we expect that it might be up to 20%. That's manageable, and that's to be inclusive towards remote people. Like it's more expensive and it's a little bit more difficult, for instance, for the managers. So like we are not expecting like so big growth, but.
Maybe someone who lives in a Koliba up in the Tatras asked that, so they can work from there. Another one, what aspect of the culture do you like the most about Red Hat?
I really appreciate the freedom and the fact that Red Hat is based on trust. So basically nobody's really hunting you down, like provide me your comings and goings to the office or give me full account of what you are working on. Like genuinely we believe that our associates are doing their best. We are trying to motivate them positively, but we are not applying this type of command and control like that I was really suffering from in my previous job. So I really like that. It doesn't work always, but I would say that like in the like very high majority of cases, like the freedom and trust that we are investing into our people actually pays back. That you don't need to stay like at the entrance of the company waiting if everybody's there at 9. Like that's very cool. Like I really like that people are responsible on their own and we trust them that they are going to stay like this.
Thank you. How many Slovaks work at Red Hat Brno? And if I may extend that question, how many of them studied in Brno previously, or how many just moved over?
I would say that the majority of the Slovaks that are working in Red Hat Brno, they actually studied there. And I think that it was something like 25% of the total population in Czech Republic that are Slovak. But I don't really like, get too much in these statistics because it's just I just feel very Czechoslovak myself, born in Czechoslovakia, so I don't really differentiate there.
Another question is kind of related to that, and it asks, if someone wanted to do a diploma thesis in cooperation with Red Hat, how would that work?
You just write me an email and I will get you in touch with the right person. That's the easiest way. Like we've got like a huge list of like all the possible topics for diploma thesis. If you have like your idea, it's fine. The only thing is that I would need to get you in touch with somebody who can be, who can discuss like this idea with you. If you want to pick idea that would be good for Red Hat. Like there are people coming that they want to do their diploma thesis with Red Hat, but they don't have like any real preference for the topic. It's also fine. We've got list of internal topics that we would like to work on with students. So just send me email and I will contact you with the right person inside, and just fine.
And as a follow-up question, the list that you mentioned, with the possible topics for theses, is that published somewhere or is it available? Does someone need to get in touch with you, or is it on the web?
I think it's not secret, but I don't know by heart the link. Like it's probably published somewhere, but as I said, like there is a coordinator for students, and I can get you in touch with him, and you can discuss whatever are your preferences for diploma thesis, and he will probably provide you the right link.
Thank you. Is there a Czech language course for foreigners?
Yes, a lot of these. Recently, based on demand, we also started classes for foreigners that want to pass the exam to get citizenship, which is like more intense Czech language course, because like one thing is to be able to live in Brno and have like answers for the most basic life situations, but the other thing is to pass as the citizenship exam, which requires like B1 level, but we have both of it.
What is the third largest nationality in Red Hat Brno?
Oh my God! Like it's Sunday morning, but I would say it's Ukrainian. Like we have a lot of associates from Ukraine, and we've got a lot of associates from Russia. So I think these two will be competing. Again, I don't differentiate that much between the like Russian-speaking group, because like they genuinely hang together like based on the fact that all of them speak Russian, even though their first language would be different. So, but I think it's either Ukraine or Russia, like the third largest.
Mm-hmm. How is Red Hat in the Czech Republic similar, and how is it different from Red Hat US in terms of diversity? Any statistics or some observations?
Well, the observation is obviously that Red Hat US would be definitely more colorful, right? Like there are people from like the whole world. They are also like a lot more involved in diversity actions as such. In Czech Republic, a couple of years ago, it was not even a topic. It starts to be a topic now, but still, as I said, like we are like mostly 80% of Red Hat Czech is either Czechs or Slovaks, which wouldn't be the same in Red Hat US. Like there would be a lot more different nationalities. And their approach to diversity and inclusion is a little bit different because of all these types of nationalities and groups. For instance, like the Afro-Hispanic minority in Brno is not very active because there's none, right? So basically, like, they've got a lot more diverse groups, whereas we are like more homogeneous. Like that's given by the fact that we are in Central Europe and not in Raleigh or Westford in the US.
There's one that has not passed through moderation, and there are some very interesting people working for Red Hat, even, like I mentioned, the shy and almost on the autistic spectrum, or on the other side, like very quirky, colorful characters.
Yes.
What is it to work in HR when the workforce is so diverse or even unusual at some point?
It's really entertaining. I really like it. Because for the last 9 months, I've encountered problems that I even, I was never thinking that I'm gonna be solving this. You know, starting from people that are like so expressive and so vocal on the global memo list that they are, that they genuinely tend to offend, like, you know, like many other participants in the global memo list, and then usually it lands on my table, you know, complaints from both sides that I need to mediate. Also people that just don't talk. Sometimes, you know, like you come there, you say like, I have heard from your manager that you have like this issue, do you want to talk about it? No. So we are, you know, mailing, like that's so cool. I really like it, like it's really enriching and it's really entertaining, and it gave me a lot of like inspiration, like maybe, you know, I was always thinking that I'm so open-minded, you know, and like the citizen of the world, and then I came to Red Hat and I found out that still it's like, you know, narrow-minded, and that there were like so many things that I took for granted and they are not. It's very cool, like it's definitely like something that I really enjoy.
So even people who are on the autistic spectrum are welcome to apply, yeah?
Yeah, definitely. Like I think we've got a lot of, like, as I said, like because of the flexibility, we are definitely able to cater also like for the needs of people that are introverted and genuinely like just don't like that much of life interaction with other people. That's just fine.
Yeah, and this is not to pick on anyone, just an observation that some of the friends, you know, tend to be very, very shy. Well, thank you so much. We're very grateful that you came here and you gave this presentation. We're very grateful that we have you know, some really hardcore techies coming here, as well as senior managers. So very, very glad that you could make it here, and thank you for taking the time.
Inviting me. I enjoyed that, and thank you for coming Sunday morning. That's cool. Thank you.
Ennek Falkovská. Okay, now we'll take about 3 minutes to switch the computers, and we'll continue.
remember, this is not a computer you can play Doom on. You can play this, if you're lucky, again. So the problem that I had was there was no internet, and also I lived in a village that there is no internet either now. So to get a new computer game, you had to work really hard to know people or just download it. That wasn't an option. So I thought, I'm going to do my own. So I want to be a programmer. I'm one of those lucky ones that kind of knew that I want to be a programmer since age of 10. I didn't want to be a spaceman because, well, there's no air. So I started to do a little research about computer languages, what can I pick. And of course, if you ask the gaming community, all the games are written in C++. You have to learn that. So I picked C++ as a 10-year-old kid, and I did this. This was my first. My hovercraft is full of eels. C out example. It took me a year. A C in, another 3 years. There was actually, I got a book like this thick about C++, and there was a definition for methods, and in the definition, the word method was mentioned 8 times in one sentence. So if you're a kid, you have no bloody clue how that kind of should work. Well, 4 years. So then I went to high school, and I'm not really sure, but why in the hell in Slovakia we teach kids Pascal. It is amazing language, though. It is so amazing that you learn it for 4 years, and then you will never use it in life. And this is how it looked in Pascal. Right, so a bunch of commands, perfect for kids. Again, you come out of the school with the language that you are not going to use, like, ever. What a shame that there is not a kind of clean and clear language that would help me to learn programming slightly easier, maybe in one command. Right, so of course, then I went to uni, again, Pascal, why not? And then I dropped out of uni, because, well, this is how it goes. At uni, funnily enough, at least for those 3 years I kind of hang on there, my ego was sky high. This was me. This is what I thought I am. That's me, number one on a pedestal. Praise me because I know how to do C++ and not just Pascal, and all the programming is just so simple. Little did I know, when I dropped out, and maybe with a half-a-year break, I found my first programming job, and this is what happened. This is me, and the ego got stamped really quickly. What happened was that I figured out that what I maybe learned and what I thought I know was absolutely nothing compared to what's kind of required in business. First of all, it was in PHP, so every single good practice I learned, I had to quickly forget, just for my own sanity. By well, people were not really programmers, so you know. If you're a person who's a designer and you are forced into creating a code because there's no proper developer around you, you're not going to produce the best code ever. And this is my first job. So my first job was just to pick up after designers and redo it. It was in PHP. And after 3 years in the company, they kind of showed me the other system they had somewhere shelved, if I can have a look, and that was written in Python, and there it was, the almighty snake. No, Python. So this was revolutionary for me. So before I was maybe average developer, but suddenly this opened the doors to a proper development for me, because Python has out of the box some pieces that are amazing. So OOP, everything is object. Well, it's really hard to grasp that a null is an object. Is there? Then, well, this was added a bit later, but still awesome. And this one is really important. This means that in PHP, if you want to learn that language or C++, you get a book. And in that book, you learn about printing, maybe a little bit of object-oriented programming, about, well, whatever gets you running. But to get unit testing, well, there's nothing. You have to find a special book for unit testing. In Python, you have a module for that. It's there. It's ready for you to use. And it's almost every single beginner's guide to learn. You know, it's there. They show you, look, do unit tests. They're great. They are, of course, great. OK, so how maybe to get a job? So this is you. You're a... If you don't know, this is from Monty Python's sketch about interview. Go for it. Watch it on YouTube. Maybe not now, but in maybe 10 minutes. What do you need to know to get a job with Python? This is a web developer actually contract. So as you can see, the knowledge of Python is maybe not enough. It's never enough to know just one language to get a job. So if you're a developer, maybe you should have a look on looking at Git. That's a cool tool. We all should use it. Test-driven development, as you can see, again, it's something kind of important even for web developer. Again, if you remember, maybe 20 years ago, web developer was a person who opened a notepad and was able to write HTML and maybe, well, 10 lines of something, and that was it. You were a web developer. Now, you have to know Python, Django, test-driven development, because, well, of course, web developer, Git, HTML, well, plenty of things. But this will land you a job. Now, if you have at least this package, you're going to get something out of it. By the way, this is a real requirement I ripped off from some site that they always bother me about get a job. I have no approval from them. I don't really care. So another sphere where you can kind of get a job is financial. In London, we have a lot of financial institutes, and they really require a lot of Python developers. They do like to pay a lot. So Django is used again here, but you got libraries like NumPy, Pandas, and a lot of requirements, slightly more than for web developer, but you know, there's the language, the Python that you're gonna learn, and you're gonna kind of use it here, and you're gonna get money from that. Do that. Now, if you want to be a data scientist, so for past few days we've been hearing here about data science, and you can use Python there just fine. Some companies do require R as well, but it is always good to know Python mainly because, yeah, you're going to use it. This one is fun because if you remember, not sure if I can go back, so this is web developer. Speaking of which, this was senior contract web developer. This was financial developer. Look at the number of requirements. Machine learning, slightly more. This is junior. And this is a real commercial, so they really want you to know this for junior. I'm pretty sure that the company is going to look for a long, long time to get a junior like that. And I found even better, and this is entry-level Python developer. Good luck. Good luck to the company. Okay, so there's a lot of different places where you can kind of use this beautiful language. As you can see, I just picked up some job titles. Chatbot developer, it sounds like an amazing path for LinkedIn. Speaking of which, if you have a LinkedIn and you have friends there who are developers, and they do have XML as a skill, give it +1. It is an amazing way how to appreciate their skill. Absolutely rubbish. So yeah, as you can see, there are a lot of fields in real life where you can apply what you really want, and you can earn money, which is great because you're gonna do what you like and you're gonna eat after with that. Perfect. So now for something completely different. How to use Python for your own good. Maybe like that. No, so there are many projects that you can kind of help out with, or you can develop for yourself using Python. I'm not saying it's a golden hammer that you're going to use and every problem is suddenly a nail to hammer with. So you're not going to maybe develop the best game ever in Python. Maybe you can, but well, good luck with that. It's like writing websites in assembler, which is hard work. But there are many projects that you can kind of do on your own. So one that I found was Couch Potato. Have you seen Couch Potato? It's a Python project for. I don't have a logo of that, but just look at me and that's it. So there's this project. You install it on your computer and it downloads films and TV series, I believe, to you. Just for legal reasons, I don't use it. Wink, wink, nudge, nudge. Pirating is bad, of course. Don't do that because, well, Johnny Depp is bankrupting, if you know. He can't afford his $1 million per month as an expense. Kanye West is also bankrupting because of pirates. His wife has to wear this dress that is not finished at all. Now, so I picked up also, as I mentioned, I wanted to develop a game. So 20 years in, no game from me. But there are games that were actually either developed in Python or the Python is extensively used there, like Civilization, I believe, that uses Python for some jobs, backend jobs. EVE Online is a stackless Python fully developed there, and this is one of those kind of successful games, and they do use it properly. So yeah, you can develop a game there. Also, if you are a 90s kid and you do like maybe the Japanese culture, do PyDance. I don't do that, as you can see. So lots of games can be developed there. Also, this is interesting project. Do you know the logo of that? It's Kiwi. It's not that Kiwi from outside with W. It's Kiwi with single V, and it's a framework that helps you to develop applications, not web applications, but the real GUI applications that you can run. And those ones, they're great because in one framework, you're going to produce an application that runs on, at least they say, all operating systems. But not only that, you can package it really easily, and you can have it like this application, it's for mobile, right? So you do one code base to rule them all, basically. First time I finally seen a framework that allows you to write an app, and it works for iOS, Android, Linux, Windows. Nobody uses that. So for example, this is one example. So this is on Google Play, I believe, and this gives you a tool that if you say, yeah, give me this URL, it will find through Google all the, hopefully, vulnerable websites that you can not hack, of course. But yeah, this is one example of an application. But there's also this Yeko, and this is amazing product. It is a product. You have to buy it, unfortunately. But this is for musicians. If you have, if you know of a a software called Ableton Live. It's a digital audio workstation, and that workstation, what it does is you can create the music in it. It is amazing. But this piece of software you install on any touch device you like, and it provides you a MIDI control to your computer. So you have it like a joystick. You can take it out. It doesn't produce sound by itself. It is just an interface for you to communicate with your computer, which sounds like a really, really cool experiment, I would say. But no, I actually use it as well, and it is a massive piece of software that that person who wrote it is really, really cool. Right. I guess it's time for me to go, unfortunately. So this is the end of the talk. It's been a pleasure. I don't think this might generate a lot of questions. Maybe none. But if you have any unrelated as well, I will try to answer them.
Thank you very much for sharing your experience and knowledge. You're right, we don't have questions, but I would like to ask which platforms besides Django have you used in your professional career?
From Python mainly, then Django was the main one, but also Flask. That is absolutely easy and simple to write a microservice on that. So yeah, that was my second favorite. I don't have a third one, if there's another third favorite question like we had before.
Okay, we already have one question. So if you are familiar with the PyBeware suite, how do you think it compares to Kiwi?
This is a really great question. I'm not familiar with it, so the answer is I don't know. Well, what I liked about Kiwi is also the community is quite active, and it's still in active development, and they have quite a lot of backing from other companies, so there is still quite a good support. Speaking of support, if you go on IRC and ask them a question, there's a good chance you're going to get an answer, maybe not 2 a.m., but you know, in sensible times. So the helpful community around that, that kind of goes for the complete Python community, which I believe it's one of the least toxic ones, or most helpful one. So yeah, I don't know, maybe the PyBeware is a lot better, so I'll have a look and I'll find out if they have a IRC channel, so I can talk to them.
Was Pascal was your very first language? If yes, would you choose a different language looking back?
No, the first language, absolutely first was BASIC. Then was C++, and then it was Pascal. The C++ was a mistake. Pascal was even worse. So yeah, if I could look back and if I could teleport back in time and choose differently, I would go with Python. It was around from 1991, and it would make my life a lot easier in that time, mainly because you know I didn't have the mental capacity to understand the structures of C++ at all. Definitely Pascal, maybe, but it was still, I think, a mistake to introduce it into schools at all. Yeah, there's not a lot of love coming from me to Pascal community, wherever they are.
Okay, how many swallows do we need to carry coconut? Can Python help with this task?
Yes, it can. I'm pretty sure it can, and it depends if they're African swallows or not. Yeah, I'm absolutely sure there is a library that you can import into your project, and it will solve that, or at least define the answer.
Okay, thank you. We have a question. Why do you think that nobody uses Windows Phone?
I know they use them. I just want to forget.
Okay, thank you very much. We have no other questions, so thank you very much for coming and for your talk. Pavel Levtak, as a backend developer, will tell us something about some good practices, how to better code. So it's your turn.
Thank you very much for coming here. I know this talk title seems like a clickbait a bit, maybe, but if you give me half an hour, I explain it why it's useful for beginners and also for more advanced developers. Yeah, so in short, I want to show you how it could make your code easier to test, to read, understand, reuse, maintain, and basically, yeah, your code should be much easier to work with. So, can you please raise your hand if you know any of these shortcuts on screen? Okay, most of you. And raise your hand if you know all of them. Okay, just a few people. I suggest that you should Google this and read about this, because there are also simple guidelines, simple practices that remind you to keep your code simple, avoid duplication, and so on. You should check it out, really. So, calisthenics. Do you know the word calisthenics? Okay, few people. Calisthenics, as Wikipedia defines it, is a set of exercises, often rhythmical, that don't require any equipment or apparatus. So when talking about calisthenics, imagine professions such as gladiators, knights, warriors in the old times. They didn't have kind of gyms we have right now. They didn't have CrossFit or things like that. So they only used body and mass of their body to exercise. And as a result, they didn't get big muscles, but pure strength. Pure strength isn't as visible on the first sight, but it's much more important and powerful. So now that we know what calisthenics is, object calisthenics was an idea introduced by Jeff Bay. It was originally an essay written in a book, Footworks Anthology. This book is right now out of print, but you can read essay online. On the last slide, there will be a link for that. And originally, it was invented, or these rules were named for Java, but later it was adapted for other languages, and currently it could be used in most languages really. But why should we bother making our code easier, shorter, more reusable? I think this quote defines the answer pretty well. When you write code, you think about it, you talk to your peers maybe, read some articles, then you write this code once, and after that you have a few rounds of code review. You need to read this code again before you make any changes. To fix a bug, you need to read it again so you can understand it. So you have to read code many times. And if we can shorten the time that is required to understand the code written, it's really big time saver. And we should do that not only because of other people, but also because we might come back to the same code again in future. So we should definitely minimize the time it will take our future selves to understand the same code. So let's go into details. I'll show you all the rules. Rule number 1 is only one level of indentation per method. You all maybe saw this code with multiple ifs, multiple for loops, nested on many different levels. This one is a really simple example of code with multiple indentation levels. Basically what it does is it combines some list of lists into a string, but it uses 2 levels of indentation for that. So if we were to use this rule, we would split it into separate methods with just 1 indentation in each. That way you have smaller methods. Each method does exactly one thing. It does this thing, I would say, perfectly. And it's really easy to test each of them in isolation using unit tests. Next example is from a project I worked on. This code is trying to fetch some products in different manners using different strategies. Yeah, it's just a short part. There were many other checks before that and after that. So simplest solution here would be to just flatten it maybe, but in else there is some code that needs to normalize the data fetched by every given method. So it's not a solution here. What we did with that is we used chain of command design pattern. So each method of fetching products was extracted into separate comments, and then we changed them one after another, and hopefully at least one of them will return us the result we expect. Yeah, so that's what we used. I'm not going to read the benefits, but you can see it, what this rule gives us. So that's the first one. Second rule is maybe somewhat controversial. Do not use else keyword. Yeah, so else can make code a bit more complicated, like in this example, because you have if condition and you have to read this condition, understand when it works, when it doesn't, and you have to keep that in mind when you use elif or else and try to go inside that code inside that if condition. Yeah, there's another simple example. What we could do to avoid else. In this case, we could just return when the if condition is met, and then continue without else. Basically, is the same code, but without else. And this way, it's a bit more easier to read, a bit more easier to follow. Another example is with default value. Very often we have some if check, and if it isn't met in else, we have default value. So what we could do instead is extract the default value before if and make it again a bit more cleaner and easier. This is how your code looks like if you have many if else's and they are also nested. On the left side is a code where you exit early if condition is met or not, and on the right side you have many different paths the code can go, and that makes it more difficult to test because you have so many more paths to cover. Yeah, so solutions, like I said, in this case would be to do some code extraction, use default value before checking condition, polymorphism, strategy pattern, state pattern. I don't want to go into describing all these patterns, but there's nice repository on GitHub, which describes all desired patterns in Python. Maybe not all, but the most popular ones. And also recently, a friend of mine showed me this question on Quora. Is it true that good programmer uses fewer if conditions than an amateur? It has around 70 answers. Most of them are really interesting, so I encourage you to go into this and see for yourself if it's true or not. So without us, we are avoiding basically complexity and code that is hard to read. Yeah. Rule number 3 is about primitive types that contain some kind of behavior. So what author meant by that is basically object value in DDD. It's a simple class that has just one value that doesn't change through life of the application. So in such a simple example, when looking just at the call method call in the last line, you can be sure what parameters are passed to this checkDate method. You have to look up the method definition or description, or look in the Python doc what it does exactly. So what we could do to improve that is to create value objects, just simple classes that contains an integer inside. And when calling this method that way on the last line, there's no doubt what is being executed there, what type of parameter you pass, and also you will not pass wrong type of argument by accident. Yeah, that gives us better encapsulation mostly, because also when you have these value objects, you can keep inside all the methods that operates on these values, on those classes. And from Python 3.5 you can use type hinting for indicating what kind of parameters you expect in methods. Rule number 4 is about 1 dot per line. And it doesn't affect fluent interfaces. I mean, you can call different methods from same object and it's okay. Like in this case, you can call first method, second, third, and so on, and it's still same object, so that's fine. What isn't fine is getter chain, where you access some when you have an object, access something within that object, and then you go deeper and deeper, and yeah, in the end you have something that is implemented 4 levels inside of your code. So that shows that maybe this piece of code knows too much about implementation of other methods, of other classes. It breaks also the law of Demeter that says you can access methods only in certain conditions. So we should use this rule that is called tell, don't ask, that basically says don't ask object for something so you can make a decision. Instead, tell object to do something for you. So in this case, you can see same code as in the beginning with board, where when we want to concatenate all the fields into a string. So in the board class, we go too deep into implementation of other methods and other object, other classes. So if you want to change any of these other classes like field or piece, you would need to change at least 2 classes. And if we use tell, don't ask principle, we wouldn't bother how field class is implemented. We would tell it, hey, here is buffer, add your all pieces to this buffer. And this way, it's first of all simpler to test, simpler to read. You don't need to know how other classes are implemented inside. And if you need to change something, you change just one class. So you don't need to touch all the code in such case. Yeah, so here also we have the open-close principle from Solid. If you don't know Solid, please look it up and read. It's very valuable. Rule number 5, do not abbreviate. Many times we abbreviate, why? Basically, because names of methods may be too long, some variables names may be too long, and if method name is too long, it could mean that it has too many responsibilities. It tries to do too many things at once. So obviously we should split that into smaller methods so each one does exactly one thing and one thing only. Yeah, so we should split that. So it's also a possibility that we abbreviate because some name is repeated very often. So maybe this code is duplicated. Maybe we should remove that duplication somehow by refactoring. There's also another use case in here. We have two quite similar but different implementation of order class. In first case, we have order class and method ship order. This order in method name is basically useless because it duplicates the name of the object we're already working on. So it doesn't really help us to work with that. It may be confusing even for a developer. And here are some shortened variable names like ACC. Is it accumulator, accuracy? I don't know. So please use just long names so there's no confusion. Your intent is clear and everybody knows just by reading it like a book what it does, how it works, and you don't need to abbreviate really, because in one context, for example, POS might mean position, but if you switch context to another one, it might be point of sale or something completely different. Yeah, so this rule is about keeping your intentions clear regarding variables and methods. Rule number 6 is about keeping your classes small. These numbers about how small a class should be is for Java mostly, but I think it would work for Python as well. So methods between 15, 20 lines, short classes, and not so many classes per method could keep it small, simple, easy to grasp. And important rule here is to keep in mind that the module and all classes in the module should have same goal, should work toward same aim. Rule number 7 that I have sometimes problem with is no more than two instance variables per class. Well, Jeff Bay tried to argue that every class should handle just one variable state. In some cases, it might be two variables, but if you have a class with more attributes than two, it could possibly be split into smaller classes, like in this case. So instead of keeping the customer first, last name, and some ID in single class, it was split into smaller class, and in the end you have value objects that store only string or integer. Well, in some cases it might be useful. In others, it could make the code complicated, but we'll get to that. Yeah, have some example of card service class that with constructor where we construct many different objects that will be used later, and we should think whether all those classes are really necessary here. Should card know about translations? It just stores products, and how much of these products are there, maybe prices. But translations is something more that should be used in when front view is rendered. Same with authentication and user services. Card doesn't really need to know whether user is logged in, authenticated, or whatever. It just stores products. So code like this probably should be simplified. Yeah, and when we have smaller classes, it's more coherent, more. You don't have many things that are not necessary there. So, yep. Rule number 8 isn't that much applicable to Python, I think. It's about first-class collections. First-class collection is a collection that holds some collection of objects and no additional attributes. So that's basically collection module for Python. You put some objects inside, you have methods that operate on those collections, but they don't do anything extra. They do just operations on those objects. Yeah. And the last one, rule number 9, is about not using setters and getters. It's not about using those accessors to get the data outside. It's about not spilling logic out of classes. So you shouldn't ask class for some internal attribute to make later a decision outside of this class. You should leave it to the class because it's its job, right? Now again, we have this rule: tell, don't ask. In this example, we have some simple game class, and in the last line you can see that we are having we're calling a getter. We add some points for destroying the enemy, and then using setter we set the score within the game. It's a better approach because all the logic is outside of the game class. So what we should do instead is this: create a method that adds score. We just tell the game that this many points should be added, and the game is taking care of how it's implemented, what's going on inside. Yeah. So I know you can see the screen. It should be a Pokemon game. So these are the all 9 rules. 2 more from me. And I don't want to leave you with just basic rules and some explanation. I want you to practice it at home. You should spend some time creating short projects, no more than 1,000 lines long. Please try to apply all those rules as strictly as possible. Even if you think that it doesn't make sense, please do. And at the end, you should draw your own conclusions. What works for you, what doesn't work. Does it really make your code cleaner, shorter, better? You should customize if you think that restrictions regarding short classes are too small, if you want to have bigger classes, for example. At my company, we organized a coding dojo where we took existing project and split into teams, and in each team was given one rule to apply to this code. And after 2 hours, we exchanged experiences, and we learned which ones were working for us, which ones we should drop because it was too troublesome to use them in real project. So some final thoughts. These are not best practices. These are good practices, but you should know when to use them, when to not use them, because they are just basic guidelines. So you're using them at your own risk. Thank you. Here are the links I promised. First one are the slides, and then others I mentioned.
Thank you very much for your suggestions, how to better code. Your talk have generated some questions. So the most voted is, what do you do when you need to continue in your function after executing if-else without using else?
Well, like I said in this example, if you can exit early from a method, just do it and then continue without else. If you need to have code to go two different ways and then do something afterwards, you could use a strategy or state pattern depending on your exact needs. Basically, design patterns are a very powerful tool you could use for most of your problems.
Okay, then you have you had a validator example. So in this example, wouldn't it be simpler or more readable to just use keyword arguments?
Yeah, it could be. We might use keywords as well in this case. I just wanted to use some Python code for each rule. Well, you have to remember that object calisthenics was invented for Java mostly, so it's not 100% applicable to every language out there. So yeah, in this case, keywords would be better.
Okay, would you encourage the use of if-else ternary operator?
Well, it depends on you. If it's useful, you have no issues understanding that later, that's fine. Personally, I would say it's okay.
What do you think about test-driven development? So when you write tests before implementation, is it worth it?
Yeah, definitely. TDD is the best thing since Solid, or it was even before Solid. At my company, we're having coding dojos every month or so, where we implement some simple application using TDD. And one rule that you have to follow is that before writing any piece of code, you have to write a test for that. So yeah, TDD is really the way to go.
Okay, what was the most troublesome rule in your project?
Well, I would say splitting the code into smaller classes was the most troublesome, because our project is quite old and quite big. So changing that would require a lot of changes in other places, unfortunately, of the same project.
Okay, thank you. We have last. It's not a question. It's just some suggestion what to see, what else to see or check. So thank you very much for your talk.
Thank you.
Okay, we will continue in 10 minutes.
Morning, everyone. I'm Jan, as you know, and I'm one of the founders of a company called CardioMe. At CardioMe, we use machine learning to solve problems with automated analysis of medical images. This is to improve understanding of our hearts, mainly. In the next few minutes, I will show you how we build tools that will make our healthcare at least a little bit more efficient. We'll see how the AI, the artificial intelligence, can solve some of your computer vision problems too. I'll briefly mention how we deploy our machine learning models into production and some techniques that worked pretty well for us. We're always keen to learn how to do stuff better. And then I will happily discuss with you what we can improve, and I'll answer questions. So where is the AI now? Excuse me. So we have autonomous cars coming on our roads. Computers are beating us in chess, poker, Go. We are getting pretty much better in many domains. But where is modern medicine today? We have been collecting knowledge, medical knowledge for centuries. We are now collecting more data than ever. But do we see anything really tangible to us? What does it mean? Even today, every 18 seconds, one person dies on this planet because of a cardiovascular disease. 45% of us will die of this disease. So that's why I'm excited about how we can apply these machine learning and AI techniques to solve some of the biggest challenges. And that's why CardioMe exists. So over the years, we have become really, really good in imaging cardiac and other parts of our body. We have different strategies to measure different quantities. These things give us new senses to have a look inside of our body without cutting it, which is really quite practical. But you know, understanding these images requires probably a lot of experience from a radiologist, and it takes a lot of time to interpret these images. When we look at these images, what do we see ourselves? I'll show you now two images from magnetic resonance of two hearts. These hearts are acquired along the short axis of the heart, which is just like if you would cut the heart through the middle. Can you see any differences between these two? I'll give you a hint. The heart on the left is healthy, and the heart on the right is suffering from an ischemic heart failure. You might have learned at school that the heart has four chambers, 2 ventricles and 2 atria. Here in these images, we see only 2 of those chambers, the ventricles, which are, this is the left ventricle, even if it's on the right. So these are the left ventricles, and this is the right one. The left one is responsible for pumping the blood into the oxygenated blood into the body. So if the left one is not working well, then we have a serious problem. You can see here that the ischemic heart failure heart has the left ventricle much, much larger than the healthy one. That's probably due to some high pressure overload of the ventricle, so it gets dilated. Can we quantify these differences somehow? Well, in normal clinical practice, what a doctor does, it takes the images slice by slice and draw contours on the images. When you draw the contours on all of the images, which are not only 2D images, but there's actually a stack of 2D images, so you have 7 slices or 10 slices along the long axis. Plus, you have a time dimension, so it's a beating heart. So you can now imagine that to quantify these differences, you need a lot of time. So you do it for every size, for every frame, And without any good software, it is actually not possible to do it practically. But with better software, you can decrease the time to something around 30 minutes to do it manually. But it's still quite a lot. Can we do it with maybe faster with things like the AI? To do this, we will need to find a good representation of the images for the computer. So let's first see how we see the images. So what a human sees, we see a picture, a photograph of the heart. If we zoom in a little bit, you might start to see the pixels of the heart itself. And if we would enlarge the pixels much more, we would get something really, really pixelated. So what does the computer see? The computer sees an array of numbers, one number for each pixel of the image. But I actually lied to you. The computer does not see this. The computer sees this. It's literally just an array of numbers. So how can we get from this array of numbers to something that the computer can use and understand and help us to extract, for example, those volumetric measurements that we saw before? One way to do it is something like what I did, for example, during my thesis for segmentation. Well, you can maybe decide, okay, I will cut off the intensities that are higher than some threshold. That will give me the blood pool. So that's the second image on the left. So once you get the blood pool, then you realize, okay, maybe, well, the aorta is part of the blood pool, the arteries are part of the blood pool. I don't want it there. I want just the ventricles or just the atria. In that case, you might find a way to get rid of the aorta. For example, there are mathematical operators that will tell you if structures are tubular, for example. You know, arteries are tubular, there are long tubes, and if you can enhance them or remove them, then you can get something that will tell you what is an artery and what is not, and what should remain. And so on and so on. So you devise new ways to measure new quantities, and it's actually quite a pain. Can we find some techniques to do this automatically? And, well, there's no silver bullet. There's nothing that will work always for you. But just machine learning, for example, is one way to do this. It is a way to code problems with data rather than by explicitly coding them. So we have a machine learning technique toolbox in our belt. How can we use it to understand the images? There are techniques that have been developed well over past 30 years. The things that are neural networks and convolutional neural networks are pretty old. They date to the early 90s or late 80s. So there's nothing really new. What is new is the computational power we have today and the massive amount of data that we have today as well. So before, it was pretty difficult to make a network. Well, you could do it yourself, but today, it's becoming really, really simple. There are Python libraries that can help you to do that. In just 6 lines of code, you can, for example, have an object recognition model loaded, images loaded, and then to do a prediction. So this can, for example, make an absolutely fantastic elephant classifier. Do you know how to discriminate Indian from African elephants? Well, if you study the elephants, you probably find out that you can measure the sizes of their ears, you can measure the shape of their forehead, and their global size. Think about it for a second. How would you code such a thing? It is really, really hard. But this thing can be now done in just 6 seconds. Can we apply these things to other domains? Can we reuse the representations that the network is learning? So as an input, we have a colorful image. We have an image that has 3 channels, the red, green, and blue channel, RGB, so-called. So these channels are then fed into a mathematical operator called convolution, and all it does, without all the details, is that it combines these 3 channels and creates other new channels that represent something different. Then you take these channels and another layer of convolution on top of that, and you learn new representations and new channels. And each of these channels is learning to represent something maybe different. Maybe some channels are good at detecting eyes, some channels are probably good at detecting faces, and maybe some are good at detecting, for example, ischemic heart disease. When we have these representations, we can extract them really easily. Again, nothing complicated in Keras, just 4 lines of Python code. You can extract these features, these channels, from any part of the network, and then use it in your machine learning pipeline to do something great. So you extract the channels, and then you feed it into, for example, a standard linear regression from scikit-learn. The great thing about this is that you don't need a massive computational power to do it. You first need to extract the features. Yes, it takes a lot of time, and you can probably run it overnight on even on your CPU if you don't have a graphical processing unit, the GPU. But once you extract the features, then you can really just load the array and train any scikit-learn algorithm on top of this data. We use this, for example, to predict where cardiac landmarks are. We train the network with images, and we output the linear regression outputs as coordinates of the landmarks. But maybe you are bored, more adventurous, you are starting to get more feel of the neural nets, and you want to explore your own architectures, you want to explore your own problems, so you might want to define your own stuff too. Well, it's not really hard. It's just like Lego pieces. Things fall into each other. If you understand what a convolution is, that it is transforming an input image into some other image that might be useful for some task, then it's not really hard. Then there are some other layers that you will understand when you start to dig into this, and you will start to understand why it's used, and that's what I encourage you. Just take the global view first, and then go deeper inside of how it works. You don't need to study the math. You don't need to learn how the acoustics works to play guitar. Just take the guitar and play it. So you can train your network from scratch. You define the computational graph. You also have some input. Then you do some convolution on top of the input. Then you do some other operation and so on till you reach some output. And then you just define the model, very simply define what is input and output. But now you need to train the model. So this is what all machine learning is about. You have some model, you have some data, and how can you find the right parameters of the model? That means, for example, the right parameters of the convolutional filters to solve the problem you want to solve. So why not to just compile the model? That's what you just have to do in Keras to have the computational model compiled, and then you fit it to the images, to the data, and the labels. And then you save it, and that's pretty much it. Now you only need to know what are you optimizing. You just learn probably a set of tools, set of loss functions that will help you to solve one or the other problem. So for example, for classification, categorical entropy might be a good thing. If you want to predict some continuous value, you might look at, for example, mean square error. But what a loss function is, it just measures how good your match of the prediction is to the real data, to the ground truth. When the loss function is high, that means your model is really bad. So the network will try to change the parameters, wiggle the parameters, so that it goes down. And this is, if you had calculus at school, you would probably know that that's what gradient of a function is, and it helps you to compute it. But you don't need to know calculus to do it. Keras uses TensorFlow and Theano as a backend, and these two libraries do the calculus for you. Now you have a trained model, and you want to deploy it to production, to be able to serve it to other customers or to your friends. Here I will show you just a very simple task, Flask server that can take your model and make it available. Again, it's super simple. You just load the model, make some route, and in the route, convert the input parameters, the input request parameters, into NumPy arrays. Then do the prediction on top of these NumPy arrays, which give you the output, NumPy arrays, and you just convert back the NumPy arrays to something usable for the user, and you put it, for example, into a JSON response and send it back. And that is it. So to make it this available, to be sure that it always runs with the same conditions, it's probably a good idea to wrap it into something like a container. So it's, again, nothing really difficult to make a Docker container today. You just define what needs to be copied into the container, and you build it. Just remember, put the model into the container. It will make your life much easier. You can share the whole container, and the whole container will do the whole job of prediction. And you can put it on a Google Cloud, on Amazon Cloud, it does not matter. Your container will do the prediction with the model. So once you have the container defined, you build it, you run it, and you can run curl, for example, to send data to the model and to do predictions. Well, of course, you could use, for example, Kubernetes to do this for you. And I think that's probably a good idea. If your Docker container, for some reason, crashes, Kubernetes will make sure that the container will come back up. It will scale if needed, and so on. But for now, we don't need to worry about scale. So now, once we have this, we can also package the model into, for example, a C++ library. And that's what we did too. It does not change the performance itself, but just for some applications we might need to do that. And it would be a pain if we would need to recode the whole machine learning in C++. Well, fortunately, Keras, well, probably TensorFlow is better for that, and a library called MXNet can do that for you. So you train your model, you define the model in Python, you train it in Python, and then you export the model into a C, you export the model, and then you can load it from your C runtime. And you can then build your own applications from that. But we're on a Python library, so let's not talk about C today. And let's see if we can reduce the time for the segmentation itself. These networks are actually doing a pretty good job, and they reduce the time from 30 minutes to just 12 seconds. And this is on a GPU, though. But think about it, too. This network is taking years of experience of radiologists, and it's learning the whole thing, well, not the whole thing, part of that, a very specialized part of that, in 1 day of training, and it can replicate almost. And this is how one of those predictions look like. They're not perfect, and some of them will need to touch up a little bit. But this is all about it. Just, we need something. At first, we need some iteration, and then we can always collect the feedback, have someone experienced correct the feedback, and learn from that again and again and again. And these things will improve. And that's the beauty of it. So we have some segmentation. We can do segmentation with Keras. You saw it's not really hard. It's in total 6 lines of code, if you know the model. And so I will probably show you some tips and tricks that we use for training deep nets. One of the things that's really important to us is to iterate really fast. There's really no need for perfection at first. Find a good model that works for you, maybe a very basic one. For some cases, deep learning is not necessary. If linear regression works for you, that's fantastic. Go ahead and use it. There's no need to go really fancy with these complicated algorithms. It's also pretty important to be able to compare which model is better than the other. And of course, as we train the models, we measure lots of different metrics. For example, for the segmentation, we might measure how close are we to the contours, if there are any parts that are scattered around that are not part of the object, and so on. But you just need to decide on one single metric that will help you to judge which model is better than the other. And that can be a combination of them all. It can be a weighted average, for example. So this is really good to choose which metric to use, which model to use. Second thing is to progressive confidence. We have seen some talks here about how we can build pipelines. And pipelines are really one of the best things to do in machine learning. Pipelines are really just code, and it is super important to have some code that is repeatable. Then you can run again, and even if you delete your data, your results, if you still have the raw data, you should be able to reproduce what you created. I also believe that the whole thing about pipelines, code, also data, should be somehow versioned. And if you do these things together, if you version them together, you can put it into your CI, into your continuous integration server, which builds the models for you as artifacts. And this is very powerful. So you can have lots of Git branches, for example, and each of those branches is one of those experiments. And then you just collect the artifacts, evaluate the models, and see which one is the best one. Third, there is really no glory in data preparation. People maybe don't underestimate the value of high-quality data, but the context-aware data is the best thing you can have for machine learning algorithms. Without that, actually, you cannot do much. So treat your data with respect and clean them nicely and put them all into a standard format. It makes things much easier if you just make one pattern of access to all of your data, even if it comes from different sources. Then, if you just don't have such a large data set, you might want to find a ways to make it bigger. So why not to, for example, augment the data? Augmentation means, for example, I have an image of a cat, and I rotate the image of a cat. But it's still an image of a cat. So the label is the same, but I have a new image. For the network, it actually looks different if it's rotated. So you can rotate, scale, you can find lots of different ways to augment the data. You can also find ways maybe to generate new data. If you have a model, a physical model, how the data was generated, then you can create your new training samples. And this is pretty important, for example, for rare diseases. If you have a rare disease, the algorithms will probably not help you very well. But we just cannot make people sick to make samples in the data set. It is not ethical. So maybe we should find ways to generate data, for example, from masks. So maybe some of you have played with things that is called it's served on affinelayer.com. And you can draw, for example, edges of cats, and it generates funny images of cats. But actually, it's pretty impressive how it looks. So this is when you have a small data set. What if you have a maybe larger data set, but not all of your data is annotated? And I think that just do it. Annotate the data as fast as possible, because the more data is usually much better than a better model. So just go for it. There are works that will help you to annotate the data faster. You can look into active learning, semi-supervised learning, that will propagate the labels to the closest ones, and you can then reuse that for training, for example. So, and finally, be practical. As I said, there's really no need to go for the biggest, most powerful algorithms to start. Just start with something simple, get the understanding, and start to build from that. So I will probably conclude now. In the ancient Greek god Asclepius, the god of healing and medicine, chose snake as his tool. And for us, Python has been working fantastically well. So I just strongly invite you to try Python. If you're doing any machine learning, image processing, AI, just go for that. Python is a very good tool for this job. Currently, we are acquiring more data than ever. There's a massive computational power coming. We have new things like virtual reality and 3D printing coming. So maybe at some point, we'll be able to print our own spare organs to replace the ones that do not work. But in the meanwhile, let's just say something more practical. We can just make better tools for doctors and patients. So at CardioMe, we are trying to do exactly that, to make doctors do better decisions and do them more efficiently. And once we have the doctors covered, we of course want to cover all of you. These things should be available to normal people, or to all of us, that we can play with our own data, we can play with our own hearts or brains or whatever you have, and get understanding of what it really is. And actually understanding it and the knowledge is something that will help us go more forward. Only understanding will help us how to make positive changes in our lifestyles and how to improve our health and how to push the whole humanity forward. Well, we'll be releasing this as an API in some time in the near future. And we are pretty excited to see what you build on top of that. I just can't wait. Thank you very much for your attention.
Thank you very much for your talk. We don't hear very much about medicine at the PyCon conferences, so it was very interesting. And we've received plenty of questions, so let's move to them. How much training data is needed or used for the cardio models?
It depends what you want to do. If you are, for example, training models for the ventricles, which are the simpler thing, if you use some smart data augmentation, for example, you can do decent predictions with hundreds of images. Hundreds means hundreds of 3D images, so those have several slices. If you want to do something more complex, if you, for example, want to recognize if a heart is ischemic or if it's a congenital heart disease, that means that the patient, the human was born with a defect of the heart. In that case, maybe you need a lot more because the variability of the data set will be much, much larger. But if you want to do just the model and just a simple cavity, then probably you will be fine with some hundreds of models and good augmentation.
What other areas in medicine do you think is suitable to apply machine learning in terms of diagnostic images, classification, recognition?
Probably ask which areas it would not apply, because analyzing images is something that you are really you're trained for years, and you can miss things very easily. Imagine that you are going through a volume of 500 slices, and it is very hard not to miss something small, for example, a small lesion or a small tumor. So in that case, the machine actually never gets tired. It can work consistently. I'm not saying it's better than human, and I actually believe that humans plus AI is better than AI alone. And that's what we should push for. And but I don't think there's an area where these techniques would not work, except for those where we don't have much data. So for the rare diseases, we probably want to revert to something like those expert systems that we have heard, or something similar.
Can you share information about the model's accuracy and recall? Do you have special weighting for false negatives?
That's a very good question. That accuracy itself is actually a very bad measure is a very bad metric for segmentation, because you can just imagine that most of the voxels that you want to segment are the background. And if I would assign a label, to every voxel a label like a background, we would get a very accurate model. And this is not what we want. So, but anyway, the accuracy, I don't have the numbers. It's around 90% average.
Next question. I think you had replied in one of the previous, but are your methods applicable on the CT images of human brain?
Absolutely. We applied the methods here for cardiac MRI and for cardiac CT, and they work pretty well. And there's no reason why it should not work for a human brain. But it depends what you want to get out of the images. Human brain is a soft tissue, and CT itself is passing ionizing radiation through the brain, and the soft tissue does not absorb the radiation real well, which means that you have pretty low contrast between the different tissues of the brain. So I would actually recommend to use MR for brains, unless there is something like you want to measure the arteries of the brain and some aneurysms and stuff like that.
Is it difficult to test and iterate your models in production? Do you require FDA approvals or any other approvals?
Yes, we will require an FDA approval. That's why we cannot share it with you all.
How many training examples did you have for segmentation problem? What GPU did you use to train the network?
So we had, for this thing, we had around 120 examples. That means 120 3D images. Each of those was around 200 times 200 times 180 space. And what GPU did we use? We used the GTX 980 Ti, which has 6 gigabytes of memory and I don't know how many CUDA cores.
What is the CardioMe's business model?
So right now we are having we can discuss that in private, but of course I'm a strong believer in pricing per unit. So actually to get just a fair share of what the whole thing costs, and to have this thing really simple to compute and to have the healthcare more accountable, to see what costs what and where the money is lost, because the healthcare itself is a big well ready for money to be thrown in.
Is Keras enough, or you also build models in pure TensorFlow in CardioMe?
We do have some TensorFlow, but Keras to start and to do even very difficult things is enough. And for those of you who maybe have watched the last TensorFlow conference at Google, Keras itself is becoming part of TensorFlow. And it will be very easy, actually it's already pretty easy, to combine, mix and match Keras and TensorFlow. So you can build your model in a very easy way in Keras and then continue building the model in TensorFlow and do it as you like.
Which learning algorithm are you using?
So I assume this means which optimization algorithm we're using for the DeepNet, and most of the time we are using either ADAM or RMS prop. And this is actually a very good question. It's good to, there's no answer that works all the time, and that's why you should have metrics and to try different stuff. And sometimes these give you intuition why they work, and you can have a look on the math of ADAM when it works better. And so, yeah, just try which one works and don't give up.
Next question is also regarding the business, probably. How do you see the future of CardioMe?
I see the future as something that is really helping all of us to answer the basic questions and the more difficult questions about our health. Not only really the segmentation is something that is necessary because we need to extract the models, these models are then used for simulations of and planning of operations, for example. But the vision is to have something that you can also like call from home. If you are worried about your heartbeat, many of you have smartwatches which measure the activity, and you can probably there are ways to at least calm you down a little bit, tell you that it's okay. But I don't want CardioMe to be something that will rule our lives. Really, we should not do technology just for the sake of technology. We should be doing technology to solve really important challenges and to really push our understanding where we can go forward. But I don't want something that is omnipresent, that will always monitor you, that will always have a look at you. But yes, I want something that will make some, for example, dashboard where you can go and see how your body works.
Okay. Who did you get the data from? How did you persuade them? What about the labels?
I've been lucky enough to and have worked with fantastic people in the past, and I think that helps to have some good agreements with them to deal with things together. And the labels were done by radiologists, and they also see that it's a waste of time to do all the segmentations themselves. It's just if you can save 30 minutes of their lives, that's something very valuable.
Why did you decide to use neural networks instead of, say, AAM?
Okay, so active appearance model, AAM. Why? It's an excellent question that was part of the discussion I've had at my defense a long time ago. And AAM is, or these shape models are great if you don't have enough data and if your data set looks almost alike. So it can work really well for hearts, for normal hearts, where you have the ventricles, which are almost always the same, and then you apply a statistical model like the AAM, and you get a nice, smooth, regularized segmentation, for example. But why not? There are cases when these shape models do not represent the data that you want. For example, as I mentioned before, the congenital diseases are there are congenital diseases where you have, for example, one ventricle missing. It's called hypoplastic left heart syndrome. And when you have this left heart missing, then you just cannot fit an active shape model on top of this data. But what you can do, if you have something like convolutional nets, is you can transfer at least part of the knowledge to your model, and the model can learn from both these types of diseases and the normal hearts, and it can find something common and representations that help you to do both things at the same time.
Oh, and the last question is, what metric did you use to evaluate your model?
So it's a combination of computational time, of distance to contour, of number of those blobs that are separated from the main part, and some other things, but I don't remember at the moment.
Okay, thank you very much. We spent the break for plenty of questions that were generated by your talk. So thank you very much, and we will continue in a couple of minutes.
Thank you. So hi everyone, I'm Yan Cheng and I work with Vox Media where I get to do cool things with data. So one of the projects that we worked on was finding related content and we used a couple of Python libraries for that. So it was a pretty cool project, and basically I guess I'll start off by explaining a little bit about why we might want to do that. So say you're reading some news article and you get to the bottom of it and you don't really know very much about the topic at hand, but you're interested in finding out more. So conveniently with a lot of news articles you'll see like this section that has related articles where you can dive deeper into the topic and find out whatever other related pieces of news have been written about it. So this was something that we wanted to build and basically automate so that you could generate it for all of the articles that we had. So the sort of very basic approach that you could take to this is basically something like word count or TF-IDF. So TF-IDF stands for term frequency inverse document frequency, and what it does is it takes into account how rare a word is in a given document versus its presence over a corpus of documents. So if a word is overly represented in one document as opposed to the corpus as a whole, then that word is probably more important in terms of determining the topics of that article. So you can use this and combine it with something like cosine similarity to determine which documents are more or less similar to each other. But that's like a very sort of simple approach. So we tried that a bit with some of our articles, but the results that it yielded weren't quite what we wanted. And a lot of the document similarity basically just, like we did some simple evaluation and it didn't quite produce the similarity results we were interested in. So then we moved on to another approach, which is word2vec. So word2vec is a neural probabilistic language model. So basically what it does is it outputs each word as a set of features, and these are represented as vectors. And it lets us find the relationships between words and articles. So the classic example of this is basically you can generate a word vector for, say, the word king, and you can subtract the vector for man and add the vector for woman, and you'll get back the word vector for queen. So this is it's a cool way of representing relationships between words. And there's also another example of this is with country and capital vectors, which you can see here. Like you have all the country vectors clustered on this side, and the capital vectors are clustered on this side. So it's a nice, I guess this provides like a nice intuitive way of understanding word2vec. And so I could go into a lot of detail about the exact way that word2vec works. So there's actually two types of it, two flavors of implementations of it. So there's skipgram, which predicts the context from the word, and it builds the word vectors from that. And then there's continuous bag of words, which predicts words from context. And again, it builds the word vectors from that. And if you want to read more about this, there's a couple papers written about it, and I have some links to that at the end of this presentation. So ultimately, we decided to use GenSim's implementation of word2vec. And it's fairly simple, so I'll just kind of dive into how we did it. So you can create a model pretty easily with like invoking this word2vec class, and then you pass in the articles that you're interested in analyzing, which is basically just a list of words, or it's actually lists of lists. And then you can specify things like the feature dimensions and the minimum number of times that the word should be in your corpus in order for you to take it account into your model. So this min count basically, it limits the vocabulary size of your model, and the feature dimensions is basically the size of a word vector. And then you can also specify parameters for parallelization depending on how you want to optimize it. And so after you've created this model, you probably want to save it so that you can go back and train it again, basically like add more documents to your model. And in our case, like we built up a system where we would read in new articles from a Kafka queue, and then every time there were new articles added, we would retrain, well, we would take the saved model and then we would add in the new article on top of it and train it with the saved model. And then another thing that is useful to kind of take a look at is the way that it gets stored. So basically, Word2Vec stores each model as a series of NumPy arrays, and each array is of size, which is that size arg that was passed into the model. And basically, we have the vocabulary size, and if we multiply that by the number of feature dimensions, and then multiply it by like the float size, then we can kind of estimate how much memory gets used when we try to generate this model. And this is useful depending on the size of your data set. And so this is basically just building the model so far. And the next steps are to actually use that to find similar articles. So for word similarity, we can use Word2Vec's most similar or similarity functions. And then you can compare like how close these two words are in the vector space. And so for our purposes, we needed to extend Word2Vec to a corpus of articles. So basically something like article2vec, where we have this model, this existing model of feature vectors for each word. And then let's say we're given a new article and we'll just go ahead and clean it up a little bit, remove English stop words from this article. Then we can create a list of feature vectors for each word in the article based on this model that we already have. So what we end up is with this new list of vectors, and this is for each of the words in the article. And then from this, we want to create a summary feature vector of the entire article. So if we kind of break this down a little bit, we basically just want to take the mean of each of the features across all of the words in that article. And then we'll end up with a summary article feature vector. And so we can do that pretty easily with the NumPy mean function. Take it across axis 0. And then we can store that, we can store the unit vector representation of that. And again, like similar to the TF-IDF approach, we can use cosine similarity to find out which articles are more or less similar to each other. So cosine similarity is basically just the measurement of the angle between the vectors. And you can kind of see a more visual explanation of this from the diagrams, where we have similar scores where the vectors have a very small angle between them, unrelated scores where the two vectors are orthogonal, and then opposite scores. So basically what we did is we went through and calculated cosine similarity between all article vectors. And for this, we were using scikit-learn's implementation of cosine similarity. And then you basically just sort by all of these values, and you get the top n similar articles. So there's a bit of code here that basically just goes through and finds the cosine similarity for each of them, and then gets the sorted list of that. And so after that was done, we ended up caching the article similarity rankings in Redis. And so this was pretty convenient, where we just used the sorted set storage in Redis, and then you can use zrange by set to get like a nice list of most similar articles, like the top 100 most similar articles. And then using that, it was pretty easy to just build an API to get ranked articles. So we built that up using Flask. It's actually just a very simple endpoint where there's a single endpoint with the article ID and the top N articles, which you pass in as parameters. And then it just returns this JSON formatted list of ranked articles. And then, so after all of this is done, we ended up building this Slack bot interface for it. So this was more of like an internal tool where you can query, and we called this bot SymBot, so you can send it the URL of an article, and then also like the top N articles that you want to see, and then it displays that nicely in Slack. So these are just like some nice things that we added on after we had the model built and stored. So after all of this was done, we had to start looking into what worked and what didn't work. So one way of evaluating it, which we were using, was it's called online evaluation. So basically, we have these similar articles that are recommended to users, and we can look at the click-through rate for each of these recommended articles. And in this case, we were basically storing that through this Slack bot. Like, we were gathering that data and storing it in DynamoDB. And so using that, we can try to look at reader interest and maybe figure out whether our recommendations make sense for users. Although there are obviously still potential issues because it's about reader interest, it's not necessarily about similarity. So it depends on what you're interested in measuring, like what you want your model to target. And then we also, of course, we just gathered feedback from everyone who used it, and some of the things that they requested was like an emphasis on more recent articles instead of older ones. And obviously this is all very dependent on audience, like you might want to weight title words more than content words. And then depending on the kind of content that you're looking at, like say if it's tech news, it might be more interesting to look at more recent articles instead of older ones, and other types of news, we might need like a longer historical overview. So yeah, that was pretty much just an overview of the project that we worked on. And I have some links to the Word2Vec papers. Yeah, that's it. Thanks for listening.
Thank you very much for a nice talk. We haven't received any questions yet, but we still have some time, so maybe you can ask if you are interested in this topic. I would maybe ask, is it somewhere online in some newspapers? Can we see it somewhere, this algorithm?
Yeah, so the algorithm, like if you go to the GenSim website, they have like a lot of information about it, and there's a lot of explanations about how this works. And since there's two ways of implementing Word2Vec with skipgram and continuous bag of words, there's also like a lot of detailed descriptions of both of them. Yeah, I can send some links if you're interested.
Okay, thank you very much. I don't know, maybe there are no questions yet. If you want to ask later, maybe you can do it during the lunch. So thank you very much. Oh,
thank you.
Sorry, we have a question. Two questions actually. What was your measurable KPI in production? ATS, more page views?
I don't know the shortcuts, the abbreviations. Yeah, the question is up there.
So I think the thing that we were interested in was more page views. So like there were different audiences for this thing that we were building. So like there's one group of people is basically just general readers of news articles, and for them the most important measure is probably page views. And then we also had journalists who were using this tool, and they were kind of more interested in using it to build like a longer historical storyline surrounding maybe one topic. So for them, we ended up just getting like direct feedback from them about what they were interested in seeing. So it depended on the audience.
Okay, thank you very much. There was another question. Well, it was not complete, I think. So I don't know.
All right. Yeah.
Okay, thank you very much.
Thank you.
Now we have a lunch break. I believe that there must be some
and regularly presents at conferences such as NANOG and RIPE. So you can look forward to seeing some Ansible on some serious automation.
Thank you, thank you. All right, very nice intro. Thank you very much. Yeah, I'm going to talk about networking equipment because let's say networking equipment is still a little bit like Stone Age compared to what guys do in like the systems kind of world. So, and in the last 10 years or so, things have been getting better and better and actually being able to do things in a little more automated, orchestrated kind of fashion. And Python has become very, very popular between like network engineers and network operators to do and automate things. So I want to show you guys a couple of, well, first kind of give you an overview what network engineers actually do and what the pain points are that we care about. And then show you a couple of Python libraries that we use that are available these days that make life so much easier than it used to be before. You introduced me so nicely already, so I don't really have to say much about myself anymore here. Let's see. Well, yeah, I started all this about 10 years ago, so I've been working in this industry for a long time. 10 years ago, we had nothing, and we were using SSH to get into a router, and that's pretty much it. And I was very lucky working at a couple of really big companies that had a big networks and gained a lot of experience there with various equipment and various vendors, etc. And all of those kind of automation projects it's all very project based. You kind of go in and you help them set up something in a particular for a particular project, and then that's kind of done. So for the past 5 years or so, I'm freelancing for those companies, just setting up automation projects and moving on and setting up the next one kind of thing. So I've seen a lot of setups by now, and I work from home, so I live in Krakow, not that far away. That's why I'm here, because we only had to drive a couple of hours to come visit. And yeah, unfortunately go to the US a lot. Hopefully not anymore these days. Okay, let's get going. So network engineering. Who's done anything with network engineering before here? Who's logged into Cisco's, Juniper's, anything? Okay, a little bit. That's good. That's good. We typically care about like all those weird acronyms that you have in networking, you know, BGP, MPLS, all kinds of like protocols that the ITF comes up with, and they try and standardize it. Unfortunately, standardizing something at the ITF doesn't mean that the vendor then ends up implementing it all the same way, which is probably the case for other standards too. So that's usually a big pain point when you come in and an implementation is different on this device and then different on another device. That's usually a big problem. And then the routers and switches that people use in like large-scale networks are more kind of that kind of thing. Like we've been putting boxes into racks that are taller than me. Typically, all the vendors that do like small kind of pizza boxes that are, you know, this size routers, they have even less on automation or interfaces available than you would like to have. So those bigger boxes tend to be like, you know, they're selling them for really, really expensive, so they kind of need to get a move on with, okay, here's an API that you might be able to do something with now, and if you get like your little MikroTik router, you're probably, it's probably harder to get there. They tend to have used their OS for like the past 15 years or so, and it's the same still, versus like Cisco and Juniper are able to develop it somehow further and further. So it's getting a little bit better if you're lucky to work with equipment that costs more money, basically. So the pain points really are that a lot of the changes, and a lot of the network engineers are just used to it. Their job on a day-to-day basis is sit there and watch that box, and then if they need to change something, they log into the CLI and they type some commands, and stuff changes, and okay, but they need to do it over and over and over again, and then if you ultimately just end up, you know, the same as in operations, really, same as in server operations too, the same way things become more automated and orchestrated. You don't want to have one engineer log into one box. You want to have an engineer be able to, you know, log into multiple, do something a little bit in a more organized fashion, monitor them all at the same time, instead of just typing everything by hand. So that's very, very annoying. And if you work with the vendors that come out with the bigger equipment, things change really, really fast. So the MikroTiks that use the same OS for the past 15 years, unlike Cisco, they came out with 4 different OSs for different routers in the past 5 years, probably. So it's all changing very fast, and you kind of need to keep up on what hardware you use and what vendor you use and what to do there exactly. And that's what network engineers are trained for, right? They go, maybe a couple of you, because I've heard the university here has a networking specialty somehow, so maybe some of you learned about this if you're here at the university, how to use, so you go into like a Cisco class and you learn how to use one particular vendor on one particular OS, and that's it. And then, a different one comes along and it all looks a little bit differently. So what do we want to automate? Because it could just all go on the same way and no one would really care, because the network engineers are happy and have jobs and just keep doing it the same way they've been doing it so far. But, learning is kind of the fun thing about it, at least for me. So changing things and doing them differently. So the things we try to automate as much as we can in networks is, of course, device and service provisioning, because like you have services, I don't know, it could be something simple like you have a router and you peer with a lot of different people, or you have some upstreams on there, etc. And those things, they change. You set up new peers, you make new agreements, you add new sessions to it, etc. So having to type this every single time by hand gets annoying. So we're trying to provision devices automatically as much as possible, and services that those devices offer. There's a lot about telemetry going on, and here data people in the first row, we need to talk about this some more, because they do give you a lot of information, right? The same way you have logs and counters coming from servers, the same way you have logs and counters coming from networking equipment. On top of that, you get NetFlow and SFlow, which gives you much more in-depth detail on the traffic that goes over those devices, which you can analyze. But the problem is there is no tools, or there was no tools available until now that would do that. Everything, even if you just want to collect SFlow data off a device, it's an incredible amount of work to set up the software, set up collectors, set it all up. If you have a big network and lots of traffic, set it up in a scalable way somehow. So there's no like off-the-shelf solution where I go, show me my graphs, and this is it. And then we've talked about this last night. You have the software, you set it up, show me my graphs, and then you look at those graphs, but then what, right? All those like data pipelines these days do so many fancy things that would be great to do on that kind of data too, because there's a lot that you could infer from looking at traffic patterns, from something there was lots of this green traffic going on, and then suddenly it dropped down to 0, and that will probably tell you something about that something went wrong, right? If you could correlate that with like your routing table or other information that you have on those devices, you would probably be able to, but we're not. This is all dreaming right now. We're definitely not there yet. Monitoring, you're all like, all the topics that I'm mentioning here are sitting right in the first row. So we've got data, we've got monitoring, we use monitoring tools. You get your logs out of like syslog, and then you want to do like some alerting on it, etc. But then you monitor for different things, right? You don't have a server that you monitor for its CPU load or something like that. You've got, you want to monitor, I don't know, stupid example, you have a peering session and they announce a number of routes to you, and suddenly they announce more routes or less routes, or one route that you know that you don't want to have, definitely. So those are all kind of special rules that you need to monitor for, and none of the software you can set up out of the box and say, okay, alert me on all of those different cases. It usually requires for you to like go in, write plugins for it, check for the specific rule set, which is a really hard thing to do, because you don't, you need to learn what you want to monitor for and then start alerting on it. So it's all a process to like getting there. One rule might be important in one network, but it might not be important at all in a different network. So I'm trying to think because there was like a story from like one network. They were very, very panicky about every time a BGP session went down, everything was terrible and oh my God, and that can't happen and that's so awful and that's so awful. And then a different network I was working on, they were like, oh, we don't even care. They just go up and down all the time. We have so much backup, like it doesn't even matter if it's up or down, right? So people have different interests in what defines their network in a broken state or not in a broken state. So that's usually an interesting thing. And then troubleshooting, I wrote that down because a lot of times the same things break in the same fashion, and then the network engineer comes in and he needs to do the same 5-6 steps to fix it. And it's always the same 5 or 6 steps. So there is ways to automate those steps as well if you know what you're looking for, right? So then if you're a big company and you have a big team of people and you write software around your network, it might look like this. And then you end up with a lot of different tools and you have all the software engineers and they just write a ton of things for it. Unfortunately, not every company has that many people that can A, write code, and B, work on things like that. So I've got some friends at Facebook, they're giving presentation about like their network software stack, and it looks like this, and this is amazing. Like, oh my God, okay, they have that many tools that like monitor for things and alert on stuff and do all those things automatically. If you're the small network that doesn't have a team of 20 people, then you cannot do that probably. So we're trying to find, open source software or things that kind of help you do this in an easier manner that are not necessarily, there always has to be some portion of it that is handwritten for the particular use case, but there is a couple of things that people can reuse all around that can be shared. So that's a nice thing. Okay, so accessing devices, because once you want to automate something on your device, you need to get to it somehow, right? Traditionally, all of devices were managed via the CLI or like Telnet or something like that. So you log in, you type things line by line. It's not transactional, so I mean, even if you take and like copy and paste 10 lines and something breaks after the 5th, boom. Now you're somewhere in the middle of your state, in the middle of your desired state, right? You wanted to be there, you came from there, and you ended up somewhere there. How do you now roll it back to either what it was originally or get to the point where you originally wanted to go? Using Telnet or CLI is a big problem for things like that because you kind of need to step by step follow what's actually going on. Telnet started going away, people started using SSH, okay, better in a sense that it's SSH, but it really doesn't help you that much in like, it's still not transactional, so it's still a CLI and it still has exactly the same problems. So yeah, that's, the same problem that you would have configuring a server over SSH and trying to like change your configs there, it would be exactly the same thing. And then you have differences between the devices that make it even harder. So if you type something on the CLI on one router, it doesn't mean that you have to type exactly the same thing on a different router. We can probably compare that to like, I want to configure my Apache and I want to configure my Nginx, right? They have different syntax, but ultimately you set up very similar things, right? You set up, amounts of sessions that you allow, et cetera, but they just end up having a different syntax. There's vendors that are kind of clean in a sense. They have one OS and they develop that one OS further across the different hardware branches they have. And then there's vendors like Cisco who basically for every new hardware branch come up with a different OS. Which is nice because the new OSs are easier to manage, at least from an automation standpoint. But then you always end up with like the old Cisco boxes that you have to manage differently, and the new Cisco boxes that you again have to manage differently. So this is all not so cool. Okay, so configurations look kind of like this. This is on the left side. On the left side, a Cisco. On the right side, a Juniper. So just syntax differences. I think this is actually pretty much the same configuration, or is it not? No, it's not. It's not. Yeah. I'll show you some. We're gonna go through another couple of slides, and then I have some demo things set up here. So we'll actually type and see some things on actual. Well, I wanted to say actual routers. It's actual VMs on my laptop, but let's say it's actual routers. So there is a lot of in those configurations. They tend to be really, really long. Like when I work for people that have very elaborate configs, there's a lot of policy and business logic encoded in like filtering or in sessions. Those things get like, 3,000, 4,000, 5,000 lines long. So you have to, they're longer than like a typical application configuration because you just encode a lot of logic in them. So it gets quite complicated at some point. BGP peering, we had that example. So if you want to add a BGP peer on a Juniper, you would have to do this on the left. If you want to add a BGP peer on a Cisco, you would have to do the thing on the right. So, and network engineers typically have those little blocks somewhere in like their internal wiki or something like that, and then they take it and paste it and change the IP address, and then there is a typo and it doesn't work, and all of those like similar things. So. That's all problematic. And this is all about writing configuration. And then there is the other side of it where you want to retrieve data from a device. So you want to retrieve data to do some kind of monitoring, for example. You want to see, how many MAC addresses are in which VLAN and behind which interface, et cetera, et cetera. So you can retrieve data from an Arista, and it looks like that. And then you retrieve data from a Juniper, and it looks like this. And you need to screen scrape, right? You need to screen scrape this to get it into a tool to be able to then analyze something on top of it. So there's to all of the software that I'm going to mention in a little bit here. There's always two sides to it. One of it is how do we get configuration into the device or access, automated access, and how do we get structured data back from the device that we can then do something with. All good so far? Okay, so then one more thing that is interesting, like after people were done with SSH and CLI access, the ITF came along and said, we're going to define this thing that is netconf, and netconf is going to give you going to give you like an RPC call access into the devices, and you'll be able to configure all the things, and it's all going to be structured in XML, and things are going to be great and amazing. Yes, they're not. They always end up, and that's just the thing that I mentioned before, they always end up implementing things in a little bit different way. So not every device that is netconf capable covers all the netconf functionality that is A in the standard, and then B, even if it returns XML, the XML that comes on from a Cisco still looks different than the XML that comes out from a Juniper. So yes, you have structured data, but it's still different structured data. So what do you do if you run a network that has, half of Cisco's and half of Junipers, and you want to monitor all of them with the same tool? You cry, exactly. You cry, and then you just sit there and type lots to make it happen anyways. Exactly. This is why I have a job most of the time, because like someone just got to unify it. Exactly. Okay, so before netconf was there, people unfortunately, so now we're getting into Python. There's a lot of libraries available that kind of make things easier, and Python has really become the go-to language for network engineers these days, which is kind of fun. I started 10 years ago, I started as like the normal network engineer type, plugging in cables and like configuring things. And 10 years later now, I'm pretty much a full-time Python programmer, which got kind of weird there, but I'm not a programmer at all, but okay. Gotta do, right, if you have to. Who has used expect before? Probably a lot of you, right? Expect is kind of the thing that people do even if they don't talk to network devices. Every once in a while you gotta do expect, then you know how painful it is. If you do expect, it pushes things onto the CLI, and then it kind of waits for a particular prompt to return, and then you can push the next line, etc., etc. And a prompt on one device looks different than a prompt on a different device. So it's the same problem again, that you have to like do things and expect differently for every single vendor. Paramico is an SSH library that we like to use in the early days before things became easier. And then once netconf came along, there were like those generic netconf libraries, but yeah, still not making things that super easy. But then people started to get smart about it, and then on top of those generic access libraries, people started writing more vendor-specific stuff. And then even vendors themselves started giving out mostly even open source libraries that people can use. So Arista came out with like their API library that people can use, and Cisco has like their own, but only for one OS and not for the others. I think they have maybe two now. Actually, the Cisco one I wrote. Like Cisco didn't, wait, did I just say Cisco came out with this? Because they didn't, okay. Juniper came out with theirs. So every vendor started giving you a library. And now let's see, because I'm got a couple of demo things prepared here. Let's see if this is gonna work now. So here, if you got a Juniper device and you've got a Juniper library, you can do things like, okay, I've prepared this in a text file, and I'm just going to copy and paste this, so I'm not actually typing this fast. But if you want to use the Juniper library, you do things like this here. Let me just paste a portion of this. Okay, so if you use the Juniper library, you can you've got your device object going on there. You can do things like open a connection to the device. This is a VM on my local laptop right now. You can load a particular configuration that you already have. You can say lock, because typically there's locking involved too, so you want to lock the config so no one else changes it in the meantime, right? So you lock your config, you load the new configuration, you say, yes, commit this thing now, I actually want it. You can do a check in between. Then you actually commit it, you unlock it, and you close it again. And this is kind of the way Cisco does it, which just makes sense, it's fine. But a different library will look differently, right? It will not have exactly the same methods available. It will just be slightly. They typically do similar things, just in a little bit slightly different way. So, okay, network vendor libraries. That's pretty much all on that. And then, since they kind of do things. In a sense, similar, and this is actually a project I was involved in too. A friend of mine and I sat down and we were like, okay, but we have 3 different vendors in a network and we would like to have a library that just speaks to all of them, right? It cannot be that difficult. And isn't that Python people that like to say that you can probably solve everything with yet another abstraction layer? So let's build yet another abstraction layer to make this a little bit easier. So my friend David and I sat down and wrote something that we called Napalm. Napalm. It started with we want to burn down those routers because we really hate them at some point, but then it ended into we found an acronym for it, and it went something about a network abstraction layer with multi-vendor support. There is an acronym in there somewhere, trust me. We're not that mean. There's NetMiko. That is a library on top of Paramico that abstracts a couple of things that are different between vendors in terms of SSH access. So you SSH into one box, and I think it's HP switches that come and give you some weird control characters before you actually get onto the CLI, and the standard SSH library couldn't deal with that and didn't know what to do with it, so it was okay. And this guy Kirk wrote NetMiko to handle them all. He just kind of tested it, and for every vendor there's a little bit of an annoyance that goes around with SSH, so that's a good one to use. So with Napalm, things look like this. So you import your Napalm driver, And then you can do things like, let's open a connection to an Arista switch. Okay, there's my Arista switch. And then the two things that I mentioned before, so you want to get configuration into your router and you want to get structured data out of your router. Those were kind of the two things that we needed, and we're like, okay, let's build them all into Napalm, because then we can just do all of the things that we want to do the same way, right? So you have, so in Napalm, if you want to go and get your interface counters, you do something like that and you get JSON back, right? And if you want to do the same for, a Juniper, it would, you open your connection to your you don't open your connection to your Juniper. Wait, this is unhappy. Why is this unhappy? Oh man. Okay, whatever. It's still trying to use the. Never mind. Well, if you would do the same for a Juniper, it would look exactly the same way, because you would just get the same structured data output for the Juniper, and we came up with JSON data that will look exactly the same way for all of the devices. And then you have problems with like one interface, one router reports that set of data and another router reports a different set of data, and there was issues around trying to fit it all into the same structure, and there's something going on. People are calling it open config, and they're trying to unify how configurations and output looks like, but sometimes it's just not possible. Sometimes it's just not, here, I have an example for this too. So if you, we're actually logged into those routers here. So this is, sorry, I don't have this mirrored here, so I gotta look that way. So this is my Arista switch that I have here, and then there's my Juniper switch. If I do like a show ARP on a Juniper, it looks like that. If I do my show ARP on an Arista, it looks like this, right? One has, what field was it here? One has an H timer, the other one doesn't have an H timer. So even if you define the same JSON output and you want to, report that back out of your library, one just doesn't have a timer. So what do? You can't fill it in, right? So you can't do the same things on all of the devices at the same time. Yeah, that's a little bit annoying, but okay, we're dealing with all of it. Okay, and then there's one more thing. So we'll do a little bit more demo right now, because network engineers are not really programmers, like I said, myself neither. So Ansible became also very popular on top of Python too, because it's, a bash script on steroids, and it's kind of easy, has a very low entry level to like trying to understand things, and network engineers were pretty comfortable with it, because they were like, okay, this is not too hard. I can figure out how to put things together in there, and I don't actually need to be a programmer to do it. So since Ansible has become so popular, we did a couple of things. And once we had all those backend libraries that we could use that were kind of doing the same thing, we started being able to actually write Ansible modules for all of this that would go and generate things. So you can take something like Napalm, and most of the vendor libraries provide Ansible modules these days as well. And then Ansible has a big like networking push going on where they wrote their own. So there's a lot in the Ansible core plus the additional ones that come out of libraries. So if you plug all of this into Ansible, you would do things like that. So we've seen. I'll try my screen here again. So we've seen the configuration over there. There's I put a little bit of basic config on those VMs just so I can access them. So I gave them like an IP address, etc. But then let's say, you need a bunch of other system configuration on your router. Like, there's a bunch of like defaults that you want to set that are around like DNS servers and NTP servers that are just there all the time. So I split this into a couple of different steps here. So let's say I want to generate my system configuration. So I go ahead and generate my system configuration, and then I go and say, okay, merge this into my devices, and I'm doing this on both devices at the same time right now. So it's pushing it out using the Napalm module onto my 2 routers right now. And then if I come back here and check my config, suddenly like NTP servers showed up, there's a name server configured up there right now, some LLDP configured and things like that. And then you could do all this in one step, but I'm trying to make this in a couple of steps here so it doesn't look. So this is on the Juniper, and then on the Arista, same thing. There's suddenly a bunch of like here. There's my NTP servers. I have a mouse here, right there. And yeah, my name servers, etc. So things like that. And then you can end up doing things even more complicated, and you start building. And like the one thing that we really like about Ansible in this world is mostly about templating, because you just have a lot of different configurations to play with that you want to template. So once you start getting into more complicated pieces of the configuration, you're trying to like build templates for all kinds of different, like you have your IP configuration, you have your BGP configuration, etc., and you put it all into, and depending on how you use Ansible, you either put it into YAML files or you plug it into like a database where your data is actually stored in, and then you actually end up having more and more templates that you can use against those routers. So what did I configure now? I configured IP configuration on my interfaces. So if we now look at this again, I've got like a couple of interfaces here now, and they got some random IP addresses. Okay, this could be like a customer interface right now facing some customer, right? And then let's say those customers want to go ahead and like set up some BGP config. So this is my customers on the Juniper, and then here's some customer configuration now on the Arista. And then if I want to go and set up the same, set up BGP sessions between them, I take my BGP template. I take my BGP template and I roll that out. And there we go. There we've got some BGP sessions going on now. So this is all getting really, really useful. And the same way we can use data retrieval and structured data out of Ansible as well. So you can say, okay, now tell me what BGP sessions do I have on this router? Are they established? Are they not established? Et cetera, et cetera. So you can do things like now, because we now have 2 BGP sessions actually going on between those devices, and it will tell you here. So this is on the EOS router, and on the Arista it has this session going on, and it's enabled, and it's up, and it's etc., and it gets that many prefixes, and doesn't get any because I don't have that configured. And then this is the same portion for the Juniper device, and it has exactly the same keys configured and everything. And this is starting to get useful, where we now can, take software on top of this and actually start using this for detect issues and, configure things automatically, etc. Okay, most of the demo worked. I'm happy. This is not too bad. I've done this demo a couple of times before, so this is on my GitHub. If you wanna look at the actual Ansible scripts, they're all online. Okay, do we have any questions? The bad world of networking. Short intro into the world of networking.
And yes, we have a number of questions.
Okay, shoot.
So, how can we automate our home networking equipment?
What vendor? Because this is always the first question, right? If you want to automate something, what vendor, what OS? You possibly need to know what version, because sometimes they support something from version onwards and not. So if you just have like a TP link in your
There's a second question that seems to be related. What cheap network hardware has good scripting or automation support?
Arista. Arista is great. I'm not sure if you can say it's cheap, but compared to Juniper and Cisco, it's cheap. So if you can get your hands on like something Arista-like, that's probably a very good idea. And then I didn't mention that, but there is a big push these days also towards more like white box switching routing, where you typically people write a network OS that you can just load on like a regular kind of server if it has enough network interfaces that is enough for your networking needs, then you can just load that up on a router. And this is a very cheap version of doing things as well. So yeah.
Any specific recommendation in that case?
For like white box switching, I don't know, Cumulus does kind of stuff like that.
Any model so we can Google right after?
Yeah, I know, Google Cumulus, and they will tell you like what they support and what hardware they support. Because like that's the problem that you have with like the regular vendors is you cannot take their OS and load it onto any box.
Right.
So that's what they're trying to do differently.
Another one. What do you think about software-defined networking? Are we going to end up with one OS to any hardware?
That's two different things, right? So having a neutral OS that you can load onto any box is one thing. Software-defined networking is trying to program more in, because this is all about like config automation and data retrieval, and SDN is trying to be more like configure actual protocols on the devices and make them a little bit, adapt them to people's needs, I would say. What do I think about SDN? I think about SDN that if we can't get config automation right yet, how are we gonna like change the protocols by ourselves? People use it and people have their valid use cases for it, but it's definitely not something that you can just take and apply and it works kind of thing. You need to have like your long-term project trying to work out what your actual needs are, what you can do differently. You can do things like, people do things like some routers, if the router is not powerful enough, sometimes they're not able to handle one or multiple full routing tables, because routing tables are getting pretty big, and then calculating out what your path is, etc., is trying to get like a capacity problem on the device. So if you take the cheap routers, you typically cannot have 3 different upstreams, and your router just can't handle it anymore. So people have been doing things like, if they know that they only send like 90% of their traffic goes to like the first 10% of the routing table and then nothing else further, people have been doing things like program their routing table specifically with the path that they need and nothing else, and to save resources on the box. You can do things like that, but then you need to have a very in-depth analysis about where does your traffic go, what kind of paths do you need, etc., etc. So it's a little bit of a bigger issue. But yeah, people are doing it, and once we can program everything, maybe it'll get easier.
Next one. Looks like you are still using Python 2.7. Any plans to migrate to Python 3?
Who asked this? I might have an idea. No, we talked about this over beers the other night. So a lot of the underlying libraries have issues and don't support Python 3. It's probably not that big of a deal, because a lot of it is just text processing, and the dependencies, there's maybe a dependency on like the netconf library or something like that. So it shouldn't be a huge deal to make it all compatible. I know the Juniper library, I think, is now Python 3 compatible. So maybe it's not that terrible to actually do it, but yeah. Okay. We probably will. I mean, the libraries we use, there's like 5 of them.
And you already answered this partially. Do you have any experience to share with tools such as Ansible, Salt, Slack, or Napalm? Slack or Napalm?
Wait, what?
Do you have any experience to share with tools such as Ansible, Salt?
Right. So Napalm specifically has Ansible modules, and then Actually, we're still kind of surprised how much it took off, because we just, David, my friend, and I, we just wrote it like, okay, we need something for our use case here, and yeah, let's open source it, maybe it's gonna make sense. And then suddenly people at actual companies like started actually using this to like manage their networks, and suddenly we get emails from like Cloudflare, and they're like, oh, we use this now, okay, cool. And they started contributing, like the Cloudflare guys really started contributing heavily to Napalm, and it probably wouldn't have lived for the past year as much as it did because of them, because they're basically managing the project these days. Because if you're using it in your environment, they actually have a full-time employee who only contributes to Napalm these days. It's crazy. So he wrote plugins into Salt. So it has like it's natively in like Salt stack, so you can use Napalm out of that. What were the other tools? I forgot.
There was Ansible and
Ansible.
Slack.
We had Napalm, Slack. Well, yeah, people do this like
notifications.
We're all chat ops now, so we're trying to, if you do chat ops and you want to integrate your routers into Slack, yeah, if you do like Stackstorm or whatever, Stackstorm has Ansible module integration, so you need like 4 steps to get there, but you can get there.
How does one handle transactions and ordering of changes? Not cutting yourself off. What about resuming when things crash mid-push?
Right, so if you use netconf, then you're lucky, because netconf pretty much has sensible error reporting, and netconf is transactional in a way, so if you send your config and netconf figures out it doesn't work, it will not apply any of it. So you know that your change did not stop somewhere halfway, but you know that then nothing of it worked. So you can do it. Ordering is a little bit of a different thing. If you have to order things, you might have to give some thought into like, what do I configure first and what do I configure second? But as long as you use netconf, transactions are not that big of a deal anymore.
Sorry, question. Across devices?
Changes across the different things across different devices. Yeah, exactly. Yeah, if you need to like have, you might need a filter set up here before you turn something on there, so it doesn't populate something wrong. I would probably do this in Ansible in some way, because we use Ansible for the orchestration around it, and if I know it has to go on this device first and on that device second, I would probably just align my Ansible in that way. Or Salt, or whatever people like to use.
And how about cutting yourself off? Has it ever happened? Or,
yeah, of course.
What do you do then?
Reboot. Yeah, typically you're careful in a sense, like, some vendors support things like rollback, so you can, like, on a Juniper, you can do like commit and wait 10 minutes, and then if things, 10 minutes later, unless you confirm, it will roll it back to the previous version. So some vendors have functions that make this easy. If you have a global network, then you're fucked. And if you have a local network, then you get in the car and drive in a data center and plug in your cable.
Do you execute raw commands via, so this is an Ansible implementation question, do you execute raw commands via Ansible on the devices, or do you actually execute Python modules there?
So what I showed just now was Napalm modules just executed through Ansible. So yeah, I think there is a module now, but it's fairly recent in Ansible that speaks netconf directly, so you could theoretically do it that way too, but why not use yet another abstraction layer?
What about security? Automation will not also enhance security issues as well, besides doing good stuff?
It's less security. It's less, in my opinion, a security issue, because you access it still the same way. So underlying netconf is still an SSH session, so you still typically use you use SSH keys or something like that if you want to do things okay. The bigger problem is not really in terms of security, but in terms of, damn it, I just had a thought and now I lost my thought. Okay, next question. I'll come back to that in a minute.
Is there any module for iOS XE?
I don't know. Maybe. I gotta look that up, but There might be an Ansible module for XE, and the important thing to like check for, because the module, not all of the modules use netconf or an API. So like the important thing to watch out for if you use modules that support older versions, they might just be CLI based, so they might not support transactions and things like that. But people have been playing around just with CLI and modules, so it kind of looks the same. Not quite the same underneath, but yeah.
Yeah.
So funny, oh yeah, funny things. So there was for Cisco, whatever, I forgot what version it was, because we were trying to figure out how to do transactions, and we couldn't really, and we didn't really want to do it on the CLI. This guy Kirk came up with like, so what if I just take my config file, SCP it up to the router, and then load it. And then it's kind of transactional, right? Because I'm loading the whole config file at once, and I'm not typing every line anymore into the CLI. So those are the kind of tricks that you have to go through if you do that.
A little workaround there, right? Oh, looks like you may have a potential contributor here. Can we contribute with migration to Python 3?
Absolutely. We'll talk about that in the car. If those Python 3 questions all come from the person that I think is driving back with us today.
Yeah, and those are our last questions. So thank you so much, Elisa. We really enjoyed you having you
Okay,
here.
thank you.
Our next talk continues in a minute.
and data skeptic. EuroPython's board member and EuroPython organizer, founder of Cassini.io and Microbit PolSCAP project. Very curious to hear what you have to share with us this afternoon.
So thank you and good afternoon. Today I'm going to talk about the project Jupyter, or Jupyter Notebook. So I think that you already know something about me, so I will skip this part. I just want to underline that if you're interested in education, both for adults and for kids, just ping me. So what is this talk about? I think I will talk about 5 points. The first one will be about IPython, so a short version of the story of this project. Then I will talk about the Jupyter project and the big split in this project. Okay, thank you. What is Jupyter today, and what can you do with Jupyter? And I think I will have a demo with the Jupyter Notebook. So at the beginning there was just IPython. Sorry. Okay. So this is the logo of the project. At the beginning was just super Python rep on steroid, I will say. The project, it's very old, more than 15 years ago. The project started with Fernando Perez, is still in charge of this project. And well, later I will put the slides online and you can find the first version of this project. So what was and what is still IPython? It's just a shell, as you can see, with a lot of color, and it's like an enhanced version of the Python. And this is a IPython shell inside a Jupyter Lab terminal. So you can see like the shell inside. That's just a web page. So before 2014, everything was together. So IPython was IPython Notebook, IPython kernel, everything was just under this project. But the project wasn't related just to Python. You could use R, you could use Julia, you could use also Scala. So they decided, okay, that's too much. We want to make a new step, and they decided to create this project Jupyter. So in 2014, during SciPy, they said, okay, we will have the last version of IPython Notebook, and from this time, everything is going under the name of Jupyter project. So you will have like the Jupyter Notebook, all the kernels will be under the Jupyter project. The only thing that will remain is the IPython part, that it's like right now is the Python kernel. And all the protocols that right now they're like used for the Python stuff. So as I said, the problem was this. So we are having this huge project, and it's not just used by Python people, by the Python community. So why do we have to call this just IPython? So they come with this new name, Jupyter. As you can imagine, it's from the planet. It's from the Jupyter planet. But it's also inspired by I will say, the main languages that they were using at the time. So Julia, Python, and R. So what is Jupyter right now? When you think about Jupyter, apart from the notebook, what there is inside this huge project? Well, there are many things. As I said, when we talk generally about Jupyter, we think about the Jupyter notebook. But there is a lot inside the Jupyter repository. So there is the Jupyter notebook, it's like the front end. there is the Jupyter app, and it's like a Jupyter notebook for organization. There is the Jupyter Lab, it's like the next version of the front end. There is NB Grade if you want to use the Jupyter notebook for education. There is the Jupyter Dashboard. I think it's something very similar to our Shiny or something like this. There is the MB Fever. It's to see the notebook online. And there is the NB Convert. And it's just a plugin to convert your notebook into something else. It could be PDF, it could be the slides like this. And there is the link for the Jupyter repository. So what is IPython right now? Well, before 2014, it was a really big project. But right now, it's, as you have seen at the beginning, just the shell and the kernel, the Python kernel that is used by the Jupyter project. But it's, I mean, you can use this kernel, this IPython kernel, also with other front-end like Interact.io, and also you can use PyCharm to code directly with the IPython shell. So, what is the Jupyter Notebook? The Jupyter Notebook is the front end. It's what you see when you launch a Jupyter instance, and it's this. So this is a Jupyter Notebook running a Python 3 kernel. It's just a web application, so you just put your website or, I don't know, localhost, and you will see this. So as you can see on the top, there is the Python logo. There is NIA logout. There is the Python version. You can use Python 3 or Python 2. I think that this or the next version will be the last version for Python 2. So as you can see, you can just type inside the cells, and you can press like the play button, and you will get the output. So it's super easy to have like a fast prototyping system using Jupyter Notebook. You can also add some text inside the Jupyter Notebook. You can use HTML, Markdown, just normal text, and that's it. But as I said at the beginning, it's not just about Python, because you can use also R inside. So it's so there is not like Python in the middle. You're talking directly with R, and you get directly the output from R. But you can also have more than one kernel on the same machine. So you can decide if you want to launch your Jupyter Notebook with, I don't know, Python 3, Python 2, Julia, R, on the same machine. So, as I said, you can use Jupyter with many different kernels. Right now, I think there are more than 40. And, of course, you can write your kernel. I think that the most used are IPython, iJulia, and the R kernel. And because they are like the one that are like developed by the community, by the Jupyter community. So the main part of this talk, what can you do with Jupyter? Who is using Jupyter for doing data science here? No one? Okay, 2, 3, okay. So yeah, you can use Jupyter for many things. Education, fast prototyping, data science. I think the right way to do data science, probably. Research, slides like this, books, and blogs also. So what about education? Well, there is this non-profit foundation called NumFocus. All the PyData related projects are under this non-profit foundation. And they also have this software carpentry and data carpentry. They teach about programming, basically. And they use the Jupyter Notebook. Jupyter Notebook is also widely used for the online courses. If you had any course related to Python or data science, probably you use Jupyter Notebook. And, well, it's also used in professional courses, like by O'Reilly. Fast prototyping. You run your Jupyter Notebook and then you start to code. That's all. You don't need to do something else. You get the output directly from the browser. You can change the code and you can rerun the cell again. And you can have direct access to the documentation in this way. So question mark and the name of the function or the name of the method. Well, what about data science? Yeah. I think that I think that right now Python is like the main language for doing data science. Maybe there is something about R, but I think it's more related to statistics. There is also the Java world, but I think it's more related to Hadoop and Spark right now. But with the, if we consider also the deep learning world, I think that Python is really the future here. And well, Jupyter Notebook is the way to do data science with Python. All the libraries are well integrated. You can use scikit-learn, you can use pandas, and you can also plot inside the Jupyter Notebook. So you can get something like this. So just a few lines of code, and you can plot directly inside the Jupyter Notebook. So what you see is it's like my slide, but this is like the output of the Jupyter Notebook. And what about research? So have you heard about the gravitational waves? So do you know that they use the Jupyter Notebook to analyze the data? So this is the link to see all the data and all the code that they used. And it's super interesting. And what about the slides? So you can just write your Jupyter Notebook with the code, with the text, and you can just convert this using the plugin NBConvert and having the slides in this way. And what about books, for example? So you can find books made entirely with the Jupyter Notebook, like in this case, by Jake Vanderplas. And yeah, it's super interesting because you can find the code and all this stuff just online, just on his GitHub repository. And the most curious thing is that you can also make PR requests to his repository if you find, like, I don't know, some typo or things like this. So it's like a new way to write books. And also you can use the Jupyter Notebook to write articles and blogs, so like with Pelican or with Nicola. So what about other cool stuff? So for example, you can publish your Jupyter Notebook directly on GitHub. They will be rendered by the GitHub engine. There is also this cool project called MyBinder, but it's just for ephemeral notebook. But you will have like a Docker machine running Jupyter Notebook. And there are a lot of very, very cool projects always related to Jupyter. There is this repository called Jupyter Incubator, and there are a lot of very cool stuff going on there. So where I can find more info, where you can find more info about this? Well, there is the Jupyter.org website. Of course, the PyData meetup and the conferences, and of course, the Python conferences. So it's where you meet people that are using Jupyter Notebook. So it's time for a demo. The goal is to have a Jupyter Notebook running on this machine. You just need to open your terminal. I'm going to use Miniconda, but I already have Miniconda on my system, but these are the commands. I will just create a new virtual ham inside my machine. I think that you can see this. So I'm just creating a new virtual ham with Python 3. Okay, I'm going to activate the virtual ham. I'm going to install Jupyter. I'm very lucky that the Wi-Fi connection is working. So, and this is the Jupyter notebook. So you can just create new notebook inside. You can change the name. And you can just start to write whatever you want. So you have different types of cell, like code or markdown, for example. So you can use the Jupyter notebook in this way. And yes, you should see your notebook. And what about the Jupyter Lab? So we can install the Jupyter Lab. Close this part before. Okay. So this is like the new front end. It will be the future of the Jupyter notebook. So right now, as you can see, as you can read, it's a very alpha preview. But I think they plan to release the version #1 before the end of this year. And well, you have a lot more. You have like the files. You can also have the text editor. You can do a lot of more stuff here. So it's much more complete. So I will say that it's like really the future. You also have like the shell. And I think you can also compose like your ID. So back to the slide. This is the future, the Jupyter future. And as I said, Jupyter Lab is the evolution of the Jupyter notebook. And gradually it will become the new front end. So that's all. Thank you.
This is really fascinating, and there's a lot happening in this community.
Yeah.
We have a number of questions. Before we get to them, let me use the moderator privilege and ask you one. Sometimes when notebooks are used for things like reproducible science,
yes,
there may be external dependencies that the script in the notebook is using. Are there any plans to standardize this in any ways, either integrate that with a container solution or something else where you would have everything, including those dependencies, so you could just rerun this in a reproducible way?
So there is this project called mybinder.org, and it's doing this. So you have like the Docker file, the requirement file from, I don't know, that you use generally with pipe, and that's all, and your Jupyter notebook. So he creates the machine from the Docker file, installing the requirements that you need.
So it's basically one command away to...
Yes, there is, if you check this project, mybinder, you will find also on some GitHub repository, launch mybinder. So you can launch directly the Jupyter notebook from GitHub.
Okay.
So it's super cool.
Does this account for dependencies that may change in the future? Like it's pointing to a tar file and that tar file will disappear from the internet? Because for reproducible science, this is pretty important.
I think you can set the version inside the requirement. So you can say just, I don't know, scikit-learn version 1 or version 2.
Okay.
So you can set like the versioning of your system in this way.
And if it's not here in 5 years, scikit that version, is it like, you know, content hashing or something that you could point to? Because if you're talking long term, in terms of science, is there any way to address that?
I think you can do this with the Docker images. So you can just store the images and you can save the images in this way. Okay. And then you can just rerun the Docker image.
We have a number of questions from Slido, so let's get to them. Ready?
Okay.
All right. Can you version control the notebooks?
So this, for now, is a big problem because a notebook at the end is just a JSON file. And it's not so easy to use GitHub with this. But they're trying to resolve this problem. Maybe not officially, but I mean, there are a lot of people that are working on this. So maybe you can find some, let's say, side project. But yes, I think that in the next months we are going to find a solution for this.
Next one. Can you convert the Jupyter slides into PDF?
You can.
Quick one. What about security? Again, question about security or authentication. Is it safe to run Jupyter Notebook server on the public web?
So, before the last release of Jupyter, yes and no, because you had to just connect to your machine. So it was like a website, an open website. But from the last release, you need a token. So you see this token from the console, from the terminal, and you need to type this token. So if I'm going to connect, okay. So let's do it in this way. Okay, so if I connect directly to the Jupyter without following the link, this link is going to ask for a token. So before the last release was different, so I could just connect directly without any kind of security system. But from the last release, I need to use this token. So if I put the token like here, I get access to the Jupyter Notebook.
If you open it again, will you also get access?
Yes, because it's like saved. I think that after this, it's saved like a cookie inside your browser. But if I use like a different browser, you need to repeat the same procedure.
Okay, so it avoids man in the middle.
Yes.
Okay.
Yes.
Uh-huh.
But you can also set a password if you want. It's more related to the kind of system that you want to have. I mean, if you run the Jupyter Notebook locally, just on your local host, it's not such a big problem. But if you run this, I don't know, like inside your university, for example, there is Jupyter Hub as a project for this. And you can use like, I don't know, Google for the authentication or GitHub.
What is the name of it again?
Jupyter Hub.
Jupyter Hub. Okay.
Yes.
Got it. Very cool, thank you. Where is the Jupyter project going? Is there a roadmap? What issues will the developers focus on in the future?
Well, there is a roadmap. And I think you can find everything online. So, as I said, the Jupyter project is formed by many projects. So, related to the Jupyter Notebook, for example, you can find the roadmap for the next releases. It's everything on GitHub.
So, some good bedtime reading.
Yes.
Have you used Jupyter to make this presentation? How easy was it?
So, it's super easy. the main problem is that you're programming, you're like writing Python, you also write text. The problem is that then you need to use JavaScript.
There's source code as a follow-up question.
Yes, I will put the Jupyter Notebook online. I just wanted to answer about the slide part. So this is like the command that you have to type just to convert the Jupyter Notebook. This is the name.
Any chance to make it a little bigger so that people in the back can see?
Like big enough?
Thank you.
Okay, so this is like the name of the Jupyter Notebook. As I said before, you have like this plugin called NB-Convert. You can convert to many things, slides, PDF, and so in this case it will convert to slides, and it will serve the slides. So I think it's easy. You just need to set, you have just different type of cell, like slides, sub-slides, notes. Because, for example, what you see, it's different because I also have this part. So it's I will say really professional because you can like take your time. You also can see the notes. So it's a good way for me to prepare slides. Of course, you don't have like the same control of I don't know, Keynote or Google Slides, but you can just write HTML and you can prepare the slides in this way.
Is it possible to use it as a way to build fancy static generated websites? Does it plug into CI easily?
So, I'm not so sure about this, but I'm pretty sure you can use the Jupyter Notebook. So you can prepare the Jupyter Notebook, and then you can just use like static website generator to generate a website from this. So for example, I'm using this with Nicola. So you can just write Markdown and your code, and then you will get like the web page.
Is it possible to use it? Oh, I just asked it. Could you make this into a desktop application like Atom is a JavaScript application?
Yes, but it's a different project. It's called Interact.io. So it's like a standalone web application based on Node.js, I think. And I mean, the main point is that the Jupyter Notebook is just the front end. So you have like some kind of API calls to the kernel, and you can just do this with any kind of front end. You can use PyCharm, for example. So yes, you have like a desktop application to use the IPython kernel, for example. So the project is called, so this is the project, and it's a kind of Jupyter Notebook for the desktop.
When you do large-scale exploration, do you somehow extract useful functionality into modules, or keep everything as one long vertical list?
So the point is that you can do fast prototyping with Jupyter Notebook, but then you can just export the Python code. So after you check that everything is working, you can just export the Python code.
Can we place breakpoints in Jupyter for debugging?
Well, that's another problem for the Jupyter Notebook because it's really, it's not easy for now to debug the code. So yeah, probably it's better to, as I said, do fast prototyping with Jupyter and then put the code inside, I don't know, your normal test background, for example.
And the last question specifically asks about prototyping. How does it compare to Zeppelin for data science, and how about prototyping?
So I'm not really an expert of Apache Zeppelin. I think this is the name of the project. I think that they are targeting to different kind of people. because with Zeppelin, it's a Java project. One of the cool stuff is that you can use different languages at the same time, so you can write like Java and Python inside the same notebook, and you cannot do this with Jupyter because you need to open a new notebook with a different kernel. So this is super cool. And but for example, I prefer the front end of the Jupyter Lab and not the one from the Apache Zeppelin. But as I said, I'm not a big expert of the Zeppelin, so I don't know how it works there for the fast prototyping or for the testing.
That was our last question. Thank you so much. This was Christian Barra.
Thank you.
And see you in 12 minutes.
in the spirit of the Czechoslovak friendship, our last speaker is Honza Javorek from the Czech Republic, who was still born in Czechoslovakia. And let me introduce him by the bio that he provided. He says, I cannot fix printers and I suck at math. I compensated by writing long texts and being talkative. Since my friends did not want to listen to me anymore, I started some religious meetups where people adore me and I think I'm saying smart things. We spread our belief by helping innocent people to learn programming. In Apiary, which was acquired by Oracle, I'm a maintainer of Dread, open source. Oh, that's a dreadful name. Oh, sorry. A maintainer of Dread, open source HTTP API testing framework. I'm focusing on learning how to become a successful leader of an open source project. This is Honza.
Hello. It doesn't look like that, but I'm quite a shy person. So I'm actually quite glad that most of the people went home already. So this resembles a nice small meetup, and I'm less nervous. This is a page I created, and I wanted to have it here while you are coming here because it's an amazing page. But my talk is about something completely different. It's called Because Web API Testing Should Be Easy. But the thing is, when I was about to prepare for this talk, I realized I hate how the talk is done, and I rewrote it and recreated it, so it's much, much better. But the thing is, it's about something completely different. And it should be called like Design APIs for Humans and Test What You Promised. But I hope you won't lynch me here for this, and you will listen to me as well. So I'm Honza, and I'm involved a lot of things around Python in the Czech Python community. I started some meetups, then I helped to PyCon CZ to happen, and I helped to pilot these and so on. So this is like half of my time, and the other half I work for Apiary, which was recently acquired by Oracle. And what we do is we create tools for Web API developers, mainly tools for to design the API in a better way. If you ask, okay, this is half of your time and this is the other half of your time, when do you actually live? That's what I'm trying to figure out for several years, and I'll let you know when I figure out. So this looks like this talk is going to be about APIs. So what is actually API? API is an interface. The I is the most important letter in the abbreviation. And when we speak about APIs, we can use this abbreviation in different contexts. And as we are Python developers, we can use it in a context as an interface of a library. I install a library from PyPI, and it has a public interface, so that's an API. We can use it as API can stand for interface of system. That means I have a service, and it gives me some means I can remotely request some data or information from the service, and that's also a public interface. That's, again, API. For instance, a GitHub has an API, so I can ask GitHub to get me information about repository, like meta information about repository for Django. Or Czech National Bank has a very simple API which gives you current exchange rates. And it's nothing sophisticated. It's actually just a text file which they put there on their server, and it has a URL. You can request it, and you can use it from your program, and you have this public API, right? The problem is that most people, like when we speak about systems and libraries, it sounds like the API is something very technical and something which connects machines. But the thing is that, in fact, it's more about users, because every API is a user interface. It looks like we work with machines, but at the end, it's the client developer who comes and tries to use the library or use the service and reads the documentation about the API and tries to, write the code which glues it together and gets the data. And that means when we are writing or designing APIs, we are designing something which will be used by a human. For instance, look at this piece of code. This is how you do an HTTP request from Python with a standard library. The people who designed this library, this interface, didn't think much about how people will use the library, and it has a lot of features. You can do anything you want with it, but you don't want to do it when you look at it. Like, you don't want to write a code like this. And then there is a well-known library requests from Kenneth Reitz, or originally from Kenneth Reitz. It has a large community now. And the API of the library looks like this. And just by a glance of eye, because you're humans as well as the humans who use the interface, you can see that this kind of interface is something you want to use. It's something which might be actually fun to use and which solves your problem. The previous interface also was probably solving your problem, but it would take you 10 minutes just to realize whether it actually solves the problem and how to use it, and you wouldn't like to write it. So this really matters. And Kenneth Reitz, author of Requests, says like, yeah, your API is a user interface and you shouldn't forget about it. So how did Kenneth do it? Like, if we want to design our own library with an API or web API, our own interface, we probably want to we want to learn from Kenneth. We want to do it in a way he did it, because his work is awesome, right? So I asked him on Twitter, and I don't know how he did, because he didn't reply. But yet. But I have some educated guesses, so I'll give you some pointers how probably he did. So how do you design interface like in a really good way? You can write tests. The thing is, when you are writing a test, you become the user of your library. You happen to be in the role of the end user, of the person who is going to use your code when it's ready. So you write test like this, you instance a request, and you use the interface, and you can very easily imagine how the person feels when uses your library. So the thing is, you have to write a test first. Only when you write it first, it helps to design the interface. Because when you do it the other way, you just write the code in a way which fits structuring your code. You write the code and you have these functions, and then when you're writing tests, you just take these functions and test whether they behave as you want it, whether when you feed them with some arguments, they return what you want. And you don't think about the interface anymore. It's just there. But when you write the test first, without the implementation, you have the time to think how you actually design the interface and how it feels. So when you write a code like this in the test, you're thinking about the interface, then you run the test, it's red, you don't have the implementation, then you implement it, and you run the test again, it's green. This way, you can design the interface, and you can first think about it. Can we bring this to another step? Like, what if we write down the behavior first? We can have a text file like this. It's just a plain text file. But you can see that it's a bit structured. It's in a language called Gherkin, and it's basically behavior scenarios. The great thing on this is that this is readable by everyone. You can put it into version control. You can send it by email. And even a person who can't code can read this, and you can have a discussion with the person. You can agree on how certain thing can work. And then you can go. And the best thing is that you can attach tests to these lines, and you can test it. So this is like machine readable and human readable at the same time. And you have single source of truth. You have one specification which says how something behaves, and it's for both discussion and design and for testing. So you can ensure that your implementation actually is according to what you promised, what you agreed. So it's testable documentation. That's like the best thing you can get. It's bulletproof. 2-in-1, like the shampoos. And then there is another thing. You know, the Gherkin scenarios are great, but it's sometimes a lot of like overhead. You want to do it on large projects and so on, but when you have a small library or a small API, you don't want to bother with 10 scenarios and then map the code with the lines in the scenarios and so on. But there is one approach which is really great and really simple, and it's RDD, the README-driven development. It's from this article. I have it here open, Tom Preston Werner. It's quite old, but I think it still applies. And it says that you just write your README first. You go and write the essential documentation for your project. That means you're not writing a full-fledged documentation like, you know, the whole docs with all the cases and so on, and you spend a week writing docs and then go to coding. No, you just write the README, the most essential information about the library, about the code you're going to write, about the interface, and you have code examples there, so you're just writing a text, and at the same time, you're designing the interface. And even though the library doesn't exist yet, you can take this file, go to your colleagues, discuss with them, hey, would you like this interface? They can say, oh, well, this parameter. And you can iterate on top of it, right? So this has several benefits. You have the chance to think through the project first and through the interface first. Then one big benefit for all the programmers is, or all the programmers which are different than me because I like to write documentation, but you know, when you get the coding and you get the library ready, you already have the docs done. You don't have to write them retrospectively, which is what nobody likes to do. So you actually have it already. It's there. And your team can use the interface before it exists. Because when you agree, like, yeah, it will look like this. I'll just go now and implement it. But they have the essential interface, they have the README, and they can already use your library. Like they can mock it in their tests, or I don't know, and you can develop it in sort of like parallel, which is definitely like useful. And it's easy to discuss the interface with everyone, readable, and it's like concrete thing. They can almost like touch it. It's not like you're having discussion at the water cooler with your colleague and explaining him, oh, what if it was doing this and that? No, you have the README, it's there, and you can read it as if it was like real project. And the interface in the README is, as I said, essential interface user expects. It's your promise, this will work. Like whatever is behind README, it's like additional features and so on, and that's something which can be broken and needs fixes or not implemented yet. But whatever you promote in README, that's the essential thing. Like it's like this library is to solve this, and I promise it has this interface. So the README must not get out of sync with code, because then you break the promise and it's like all wrong. You just, it's step missing there. You know, you promise something, you design it first, then you implement it, and then you actually have no way to say, well, I implemented what I actually designed. So how do we ensure implementation matches the design? Well, we can ensure it by testing the documentation. In a similar way as the Gherkin works, we want to have the bulletproof 2-in-1 here. We have testable documentation. Python has this built-in doc test module, which can go extract the code examples from your README, and then run your library and match and test whether the code examples and the reality actually like matches. And this is amazing because then you can actually rely on the fact that what you promised in your README and what you designed, that it's what you implemented. So you can write the README, you can agree on the interface with your users or colleagues or whatever, and then you have this test which ensures that it won't pass until the interface is fulfilled as it was promised. And if you want to keep it like that forever, you can put this into continuous integration, and if you break it in the future, you will break the build and tests won't pass, and bye-bye, you have to fix it. And just imagine, what if we could design and test web APIs like this? Wouldn't it be like great? So the thing is that you can have a markdown file, almost the same format like your README, and you describe your API like that. In simple words, it has some sort of structure, but you can say like, hey, get me this endpoint, and you can write there in plain text like what is it good for, what is the response, what is the status code, and what you get, and so on. And it's an actual format. It's API blueprint, and it's just markdown file. It feels like README, and it's human readable, machine readable. And the machine readable part is very important because then you can take a tool called Dread and test your web API against the designed interface. So you have document, it's a single source of truth. Yeah. So this Dread tool is open source, it's a library. You just install it, you can run it in your console. And it supports multiple languages for like to be extended with. And you can put it into continuous integration. So, and again, you can ensure that the the contract is all right. It's kept. So what happens here? You have the document. You design the interface there. You design it before you start any coding. You can discuss the interface. And the document is just plain Markdown. And while it's plain Markdown, you can still parse it and do several things with it. Like you can generate HTML documentation from it. You can generate mocks for the users of the interface to use it before it actually is implemented, so they can give you feedback. And you can test the implementation, whether it fits the design interface, and ensure that the implementation is according to what you promised and what you agreed on. And this is what we do in Apiary, and how, like, what our tools like help you with. But the concept is important on itself. So testing implementation against design allows you designing before implementing, because then you can keep the promise. Designing before implementing allows you better design. And the Dread tool allows you better design in this way. And I have a demo. I don't have much time, but I'll try to speed it up. So I'll install Dread, which is itself in JavaScript, but it doesn't matter. And let's create a simple API here. So let's start with something like this. That's some kind of header, but now I just like cats API, and let's say this API allows you to get various cats, which is amazing because internet is full of cats. Get cats, and now I have like response 200 JSON, and here I have like example of a response. So let's have cat called Schrodinger's cat. Or cat called Garfield. And let's give it a color. It's just example. And let's see, I'll save it. So I have this API MD Markdown file. So I have this Markdown file, and I designed an API. I didn't think about it much, but when you design an API, you should. You will have more time. And now I'll try to like implement the API and test it. So I have Dread here and the API. I don't have any implementation yet, so I'll start with something. And I'll use Flask, which is simple framework for Python. I'm not very good in remembering things, so I just take their hello world example. So yeah. Oh, that doesn't matter. So I have this hello world example, And that's my implementation of the API. Well, doesn't look like, but that's how it works with testing first. So I'll run. Yeah. I'll run my implementation. API ID, right? What was it? Localhost 500 or 5000. Yeah. Now I tested that my implementation doesn't fit the design, right? I can see that status code is not 200 because it's requesting cats in my API. There's no, in my implementation, there is no endpoint cats and so on. And the content type doesn't match and so on. So the implementation isn't really good. So let's change it. And I'll just take whatever I have here and I'll put it into a very sophisticated database. And I'll use JSONFI. Yeah. So like this. So let's see whether my implementation now fits the contract. Well, I'm lost. Help me. Okay, works. And I don't have much time, right? Okay. So I want to show you how we can use actually like Python to extend this kind of behavior, because this is a default behavior. You might wonder if you change Garfield to something else, yeah, it will smartly test the thing. Like it doesn't do one-to-one check. It tests the structure and so on. And if you want to extend this default behavior, you can use various languages, and one of them is Python. And you can do that by, let's see, I will have a simple authentication here. Let's say if, I need request here. Request. If request header called, authentication isn't super secret token, I'll abort that the user can't access the endpoint, otherwise I'll provide him with the data. And this is something which is not very easily you can't very easily describe it in the contract, because you can tell user that there is authentication header, but you can easily test it this way. You can put the actual token. Usually, like I could put my super secret token there, but when you have real application, the token changes, and you can't just put it into the documentation because it's a secret thing. So you want to attach a token to your calls, to Dread's calls. So you install Dread hooks in Python, and now I can create another file, which is like import hooks as hooks. and I'll add my super secret token request headers. Equals my super secret token, which is this one. Like this. So now I wrote a simple hook file which extends the behavior of thread. Before each request, this function will be run, and the transaction with thread does to test the server will be modified by this my code, which adds HTTP header with some super secret token. And when I run this thing, it's wrong, and I don't know why. Yeah, because I have the file wrong. Okay, now it should be okay. Request, okay, another mistake. Now it passes. Okay, I made some mistakes in the hook file, but the thing is, you can, if I didn't do this, it would fail, because the server wants me to pass the authentication header. So this way I can extend the behavior. And that's all. Well, it's not. I have one special file, a slide here, which says, remember, think first, design first, doc first, test first. Basically anything, do anything first before you start coding. It's good for you, it's good for health. Discuss the interface design before implementing it. Use the interface before implementing it. And have your interface design as a single source of truth. Strive for having testable documentation, because then you can ensure that what you promise is fulfilled. And yeah, test implementation against the design. And I think that's it. Yeah, that's my company. If you want to work with me, let me know. And I have stickers.
It's been great. There's a number of questions that you got. Okay, the one with the most upvotes, if I see right. XML or JSON or something else?
I guess whether XML is supported format for testing like this. Well, the JSON support is like the largest. XML, but basically you can put examples of any payload there. So you can put text plain there, you can put XML there, and it will work. You can test it, but the smart comparison which is implemented there isn't ready for XML very much. But since you can extend the testing process with your own, like you can do your own assertions and so on. You could easily use this and match like the bodies according to your needs. And Red will do at least the rest, like the status codes and all this. So yeah, it's possible. It's not completely out of the box at the moment.
And more generally for APIs, would you use XML, JSON, YAML,
like that.
something else?
That depends. Like I would use JSON for most of the APIs, but if I don't know, if I'm doing an API where I'm sharing, I don't know, like GPS data, there are like standards like GPX or KML or something like that. So it would be like why to invent something else when there is standard which is XML, and that makes most sense, and you have most tooling for it and so on.
So depending on the consumer.
Yeah.
Yeah. Any thoughts? Oh, this is a little tougher one. Any thoughts on working for a company that has reputation often described in very negative terms, that is Oracle?
Well, that's, I would say that's a challenge.
Please know this is being recorded, okay?
No, that's a challenge. Of course, it's like, it depends, like it's some negative PR and sometimes positive PR. It's like, yeah, for me, it's a challenge. Like, let's show that, let's teach the big company that you can do things in a different way.
We will not grill you on this one anymore, okay? Your favorite documentation framework besides comments and README?
Besides comments and README. Documentation. Okay. Well, for instance, on Dread, I have documentation. And I use currently there's mkdocs, and it's hosted on Python on read_docs. And I like Markdown for its simplicity, but I like restructured text for its features and how it can interlink things and have these warning blocks and so on. So I'm a bit like torn between those two, because not many people out of the Python community know restructured text, but Sphinx and read_docs and all this, it's completely amazing. But you know, Markdown is then you need other tools, or Sphinx supports Markdown, but it's, you know, it's like half the features and it's not very good. And especially if you host Markdown on read_docs, also there's like 20 issues which are like, oh well, we don't support it that much. So my favorite would be Sphinx and more feature-rich Markdown or something like, because it's better for contributions. Like if people come and they see restructured text, they often get scared and run away, but I don't know.
Thank you. Next question. Will GraphQL replace REST APIs?
I'll try to keep it short. Let's say we had this SOAP and thing which was like basically you created something on the server and you didn't care much about your consumer. And sometimes even like with REST approach and with HTTP like JSON and this thing, people design it in a way, they just design it like, oh, this is how we want to build the API, and you use it, and we don't care how you use it and if it's good for you. And GraphQL, I take it as a revolt from all the client developers which say, no, now you will listen. You just give me what I need, and we don't care how you cache it or how you find the data. I just send you a query, and you just get me the data, and that's good for me. And that can be good for some scenarios, but I think it would be better if the two sides could just speak to each other and create APIs which are good for both the server developers and the client developers, and not like, well, I don't speak to you, give me the data this way. So the ultimate answer is, in my ideal world, we would stay with well-designed REST APIs. And at the same time, I think GraphQL is a good innovation, and it can live alongside REST APIs. It's like WebSockets is also a different kind of API and it's good for different things, and it perfectly lives alongside REST APIs, not replacing it or something.
So in other words, the transition that we saw from SOAP to REST APIs, pretty much, you do not see a similar thing happening here. You think more like these two.
Well, it can happen. I'm not like Nostradamus, but I hope it will live like together alongside each other.
Okay, thank you. How do you persuade the developers to keep the README in sync with the code?
By tests.
Yep.
That was the presentation was about.
Yep. By the way, this was asked at the very beginning, so that's probably why the question was asked. Another one, why is Dread called Dread? The GitHub README does not seem to address that.
Okay, well, Dread is called Dread because there's this cool comics called Dread, and it's a badass judge cop from dystopian future, which just comes to you and judges and executes you on the street because there's no time. There's so much crime in the future. There's no time for real like trials. So you better listen to the law and don't get Dread angry. And this movie, there are 2 movies about it, and this movie is really good. And the older one is, I think it's with Sylvester Stallone, and that one is quite fun too.
You could have a hook, you know, if someone has a test that fails, it would do something, you know, like delete a random file or something, you know, to punish that person for.
I am the law.
Another one. Is it possible to use Dread with binary output formats like protocol buffers?
Oh well, not really, not yet. I have still open issues about images, so something more complicated would bring me a sleepless nights. But yeah, basically binary. That's difficult because you have to test it probably by hooks, because you can't really easily declaratively write it into the specification of the API. And well, yeah, and we have to at least ensure that you can go around this limitation in hooks.
What do you think about HAL, probably referring to hypertext application language, but I could be wrong? Isn't it an overkill?
Well, I like hypermedia. HAL is one of the like basically implementations or like formats to use it for hypermedia, and I would probably choose different formats, but for hypermedia. But at the same time, I can see that HAL is one of the like simplest approaches, and it's like there's most tooling, but I think HAL doesn't give you the full power of hypermedia, because hypermedia is about links and forms and all the things, and HAL has just half of it. So if you go like full hypermedia and you try to find a format which will give you all the power hypermedia offers you, you might not consider it overkill because you get all the benefits. But if you go just with HAL, you can end up just with, you know, responses full of links, and it might seem like overkill.
And are you planning to include a way to write comments in apiary? It's a question about apiary.
No, not really, because we want this to happen in different places. Like basically we have GitHub integration, and in an ideal world we would have integrations with others like software where you could discuss the code, version the code, and so on. Like, I don't know, there's not just GitHub, but you know, Bitbucket, we would have the integration for ages if they had commit API, and that's a different story.
Another one? Thanks. This was very eye-opening. And another question about binary formats, which you already answered. So thanks. This was very eye-opening. And the very last one, any thoughts on Swagger or OAI?
Yeah, it's supported in Dread. But in my opinion, well, this Swagger community is originally very oriented on a different way to approach this. That's like I write code and I generate the docs from the code, which is which goes completely against this design first approach. And they are trying to be design first as well today, but for me it's much easier to design an interface by writing a human readable document and discuss the design than to write a YAML or JSON file and going this way. But if somebody needs it for integration and so on, well, yeah, it's supported. You can test your API described in Swagger by Dread as well.
This is our last speaker today, Honza Javorek.
Thanks.
And you may be wondering, what do you mean last speaker? There is one more in the program. Well, a little thing happened. Andriy Soldatenko